Hey, hello, hi everyone. Hello, hi Sayan. Thanks a
Hi,
lot
hi,
for
hello, Karan, hello, everybody. Very good morning.
hi. Hi everyone. Today I think we'll be covering LLMs. We'll be doing a deep dive on actually what LLMs are and how do they function. And for that, Sayan would be here to take that up. So yeah, over to you, Sayan.
Why, thank you so much. Thank you so much, Mr. Karan, and very warm welcome to the audience as well. And it's wonderful to see all of you turn up for this session. And I'll quickly start off with a very quick introduction about what I do and what I'm involved in. And from there, we will get into the specifics of the agenda of what we will be covering and how we will basically go about things. Uh, So myself, Mr. Sain here, and first of all, sorry for the small delay. We were waiting for participants to join in. I think pretty much everybody in right now, so we good to start on. So myself, Mr. Sain here. I've been involved in the industry for near about 14 years now, and presently I work as a consultant for Walmart. And I'm also extremely passionate about teaching. Apart from the day job that I do, I'm also extremely passionate about teaching and training professionals and executives in the field of artificial intelligence and machine learning. I am a visiting faculty with several of India's premier institutes, and also I do a lot of trainings for foreign universities also, like Purdue University. I do training for Caltech. I've been invited abroad by Singapore, universities as well. So I've pretty much traveled a lot for guest lectures. So really, really passionate to talk about AI ML, and there's something that we are also aiming to do as part of today's masterclass. Today's masterclass is effectively about language models. I know language models are a big talk of the town today. We have been hearing about ChatGPT and NLP and whatnot. ChatGPT is a big buzzword in today's world, and part of today's session will be to give all of you a bit of a glimpse into what it really is. So, so what is this session not about? This session is not about hype. So I'm not going to come in here and talk about that. Hey guys, this is Chat GPT, and this is what you can do. This is the resume that will be created, and all that nonsense. That is something that YouTube influencers do. What we are trying to do in this session is we are trying to tell you use cases. We are talking about the hows and the whats and the technical details behind what actually happens. So I'm going to try to strike a good balance. In the initial part of the session, we will start off with a introduction to AI. We'll talk about NLP generally. So the initial part of the session, we'll talk about natural language processing, what natural language processing actually is. And we're going to focus the initial part of our session also into some of the use cases of NLP in different aspects, in different domains. So we'll talk about NLP use cases in different domains in different aspects. So how NLP is used in different aspects. So be it a sentiment analysis, a topic modeling. So how do we use NLP in different aspects or different avenues? So that's how we're going to be talking about the talking about the whole thing here. That's the whole objective. That's the whole objective here. We're going to be discussing NLP in different ways. And then we're going to be slowly coming to the aspect of language models, understand their importance, what language models are used for, do a bit of a deep dive into the architecture of a typical language model. We're going to be looking at something called encoder decoder architecture. We're going to look at maybe a very small demonstration of how neural machine translation is happening, give you a very small demonstration of the whole thing with respect to a recurrent neural network. Very basic introductory idea I'll give you. And from there, we'll get into maybe a bit of a Q&A, uh, something very unique that we do in in these sessions is we'll do a small quiz, and there are goodies to be won there as well. So what we discuss all through the class, I'll be arranging a small icebreaker quiz to test all of you on the different things we talked about. And finally, a very important part of the class will be right at the very end where we talk about AlmaBetter. And even I am a faculty and even I'm a trainer with AlmaBetter. And something that we'll try to talk about is what are the different ways and how is AlmaBetter different and what do we do differently rather than a plain vanilla bland training program where you attend sessions, you do exercises, you do quizzes. It's pretty much the same thing, right? So how is it happening differently at AlmaBetter? The program walkthrough and how are we unique, especially from a job placement and from an outcome perspective, is something that the team and Karan and myself will also focus on a little bit towards the end of the session. So that is the general flow and agenda of how we will be uh, taking and going over the topics. All right. So starting off with artificial intelligence, and it all starts off with AI and what AI actually is. So what is AI? How do we look at the term AI, and what is the meaning of the term AI? Because all of what we are discussing, language models, NLP, they're ultimately part of the wider gamut of what we refer to as artificial intelligence, right? And AI basically came about as a concept that was basically it was a term that was basically um, it was a concept that was basically proposed back in the 1950s. 1950s is when the term AI was first coined. You can see 1943, 50s around that period when the term AI was first coined. There was a Dartmouth conference that happened uh, where all the founding fathers of artificial intelligence they came together, and that is how formally the term AI was actually coined based on the Dartmouth conference. That's how the term AI was again, as I said, formally coined based on the results of the Dartmouth conference. Okay, and the term AI was basically broadly used to describe a technology wherein we are able to make machines intelligent and we're able to make machines do and act and you know work in a way humans do. Okay, so that's the way we define artificial intelligence. If you're able to make machines intelligent in a certain way, we're able to make uh, computers do and act in a certain way. That is what we basically refer to as AI. So what is AI once again? So AI is basically that field of computer science that gives machines the intelligence to do and act certain things that humans do. And we felt the need for this in a big way back in the 1950s. There were a lot of things that we were doing in a very manual way. And if we can figure out some way to automate the whole thing, that's basically the invention of the term AI. I'll give you a very simple example. Now, I know when we talk about artificial intelligence, we talk about all these fancy examples like self-driving cars and whatnot. That's the way we typically think of the term AI, right? But one way to understand AI would be even if you look at the AC that is running in my room, I've got an air conditioner running, and this AC is basically running in auto mode. The AC that is running in my room right now is set at auto mode. And I basically set my temperature at 24 degrees Celsius, 26 degrees Celsius, let's say 27 degrees Celsius. What do you think is happening behind the scenes? So the moment I set my temperature to 27 degrees Celsius, what is actually happening behind the scenes? It's, it, you can imagine that there's a small piece of code that is written behind the scenes. There is a small piece of code that is written behind the scenes, and the code is working in a certain way, and it is detecting constantly what is the room temperature. Through the sensors, it is detecting the room temperature. And wherever the room temperature is exceeding 26 or 27 degrees Celsius, the AC is starting to cool. And wherever the room temperature falls below 27 degrees Celsius, the AC is stopping the cooling. So it is basically working on the basis of a fixed set of instructions. If you look at the way the air conditioner is working right now, it is simply working on the basis of uh, a set of predefined instructions, and it is an intelligent agent. Now you might look at that AC and say there's nothing intelligent about the AC. What is there in the AC? I press a button, something happens. But remember, there is a little bit of basic intelligence it still has. Mind you, the moment I set my AC to automatic mode, I don't have to manually monitor my AC. I don't have to manually monitor the conditions at all. It will simply operate on a certain way. There is no need to manually monitor the AC at all. It will simply operate in a certain way. And there is no need that I have to manually monitor the conditions at all. That's one way to look at it. It will simply operate in a certain way. It will basically operate under certain conditions. And that is the way the AC will basically work. It is a very simple, it's a very basic form of artificial intelligence. If you look at the air conditioner, the way it's working, It's a very basic form of artificial intelligence. Okay, we can talk about other examples of basic forms of AI. Not to talk about something very advanced, very basic forms of AI. You can talk about a simple automatic washing machine. Have you thought about how an automatic washing machine basically works? There are different modes it has. It has different modes. It has, let's say, if I press a button called monsoon mode, what will happen if I press the button monsoon mode? If I press the button monsoon mode, what will happen is a preset instructions are already stored inside the washing machine of how the machine will function. There is a particular wash cycle, dry cycle, rinse cycle, and so on and so forth. And there is a particular mechanism of how the machine is supposed to function. I repeat, there is a particular wash cycle, dry cycle, rinse cycle, everything is there. And there is a particular mechanism specifically with respect to how the machine is supposed to function. There's a specific mechanism with respect to how, once again, the overall machine is supposed to function. So that is a way how we look at the idea of artificial intelligence. Anytime when you write code, I'm pretty sure everybody has, irrespective of whether you have experience in programming or not, everybody has been exposed to Python or some kind of a programming language. You've at least heard of it. You may not even know what a program is, but at least you've heard of it. For somebody who is completely new to this topic of programming or coding, it's that very scary thing which developers do, right? Coders actually write something, they write an application, they write some functionality. What do? They're actually building an AI system. Even in the operating system for that matter, even software for that matter. What is software? What is the operating system? Think about your Windows operating system. Think about your Mac operating system. Think of it about your Android operating system. What is that? It's a series of instructions written. So the developers or the so-called coders have written tons of instructions, and they have basically instructed the machine to execute a particular thing in a particular way. And that is the whole idea of what we refer to as artificial intelligence. This is the process of making machines intelligent. We are writing a series of instructions. We are writing explicit code. We are writing a series of instructions, and we are basically making machines do a particular thing in a particular way. That's the way we think through the idea behind what artificial intelligence actually is. So it is basically making machines intelligent. It's writing a series of instructions, a series of rules, and we are making machines intelligent in a certain way. And that's the way we think through the whole idea behind what artificial intelligence is basically all about. That's the idea behind what AI is basically all about. Okay, that's the idea behind AI overall. So anytime when you write a piece of code, next time you hear about a website or a web application, or you think of a developer who is creating a website, so technically they are building an AI agent. Imagine a website. How does a website function? I'll give you a small example. I know this topic can be a little new for some of you. Excuse me, guys. Just give me a second. Okay, sorry guys, I was having a small cough here. So if we just quickly take a look at this use case, I was just talking about the use case for what artificial intelligence actually is. Even a small example of creating a website from scratch. If you look at a website, what is a website actually? What is the web application? So this is a website. Now, all the content that you see, the behavior of the website, a particular set of things happening. When I click a button, something happens. When I click a link, something happens. When I click on this particular link, it goes to a different page. When I click on this link, it goes to a different page. We see a set of things happening. When I right click and click on inspect. So what I did is I right click and click on the inspect button. So I click on right click and I click on the inspect button. So when I do that, there's right click and I click on the inspect button. So this is the set of code that I actually get to see. So what we are seeing on the screen right now is a set of instructions, is a set of code, and it is nothing but HTML that we're able to see on the screen. This is nothing but HTML. HTML body tag. This is typically how we have seen HTML code. There's body tag, there is head tag, there is div tag, there's paragraph tag. So this is actually code that's written. Somebody would have actually written the instruction, and they're basically dictating how the website will function. That is nothing but AI. Now, it's not the advanced kind of AI that we typically think of, like, hey, self-driving car or a Sophia kind of a robot or a humanoid robot, but this is also artificial intelligence, isn't it? Isn't it incredible that when I click a button, when I press a button, when I click a link, the agent just knows where to point me to. Isn't it incredible? So when I click on a button, something magically happens. When I enter my details, imagine that you go to facebook.com and you click on sign in, you enter your username, password, and you click a button, something magically happens. And if you enter a wrong password, the prompt automatically comes in saying, "Hey, wrong password enter." That's magic. It's almost that is intelligent. The agent is able to figure out what to do. That is a simple way to think through artificial intelligence, right? Any kind of software, any kind of application. Look at the Android phone. Okay, if you try to, if this phone goes to power saver mode, if the mobile phone battery goes below 15%, okay, the battery saver mode is automatically enabled. And the moment the battery saver mode is enabled, a series of things will start happening. And what are those examples of a series of things? One will be the screen will dim. When we try to turn on the camera flash will not work. When I try to turn the flash mode of my camera, the flash mode of my camera will not work and it will automatically turn off. The flash mode of my camera will stop working. So that's one way to look at it. The flash mode of my camera will basically not work. Who has defined these instructions? It is defined as part of the operating system. If you take your Android phone, if you keep it under the sun for a long time, what will happen? Automatically, it will go to thermal shutdown because that feature has been again it has been hard coded in the functionality of the Android phone. If the temperature of the internal components goes beyond a particular degree, if the temperature goes beyond 25 degree or 30 degrees Celsius, what will happen is it will automatically enter into thermal shutdown mode. That's the way to look at the whole thing overall. Right. All right. So this is a very simple way to think through AI. We have got lots of use cases. I won't be getting into too much of things. We have all heard of these use cases of AI being used in different ways. But one thing I really wanted to help you appreciate in this initial part of the conversation is AI doesn't have to be something too advanced. So right in the origins, 1950s, when the term AI was first coined, it's something as elementary, something as basic as a software, a typical computer program, or a simple system, a simple circuit-based system that we see, even a fire alarm for that matter. Think of a fire alarm, a smoke detector. What is that? It's an AI system. It detects smoke and automatically the smoke detector triggers an alarm. Have you thought about it? Now, it might seem like a very simple system, but it's a circuit, it's a trigger. And right in the 1950s was the same time Boolean algebra was invented. So Boolean algebra was basically the idea behind AND gates, OR gates, NOR gates. So the concept of gates were invented back then, and these were very, very new concepts at that time. A simple way to think of rule-based AI is a set of if-else instructions. If this, then this will happen. Else this will happen. If this will happen. Else this will happen. That's a very simple way to think through what these kind of systems are. Okay. All right. Now coming to the world of you know coming to the world of how we look at AI for solving different types of problems. And there are two different domains that I would like to talk about: AI manifestation and its applications. One is basically computer vision, and the second one is NLP, which is more in line with today's masterclass. What is computer vision? How do we understand computer vision? What is the meaning of computer vision? So, computer vision is basically a field of AI that effectively enables machines to see and perceive something. It's giving machines the ability to see and perceive things. It's not only that you're able to see something, but you're also able to perceive something. Like a Google Lens, the moment you take a picture with a Google Lens, what happens is you're able to capture the image, you're able to see what you're seeing, and you're able to process what you're seeing. So the ability to see and perceive and process information is what computer vision is all about. Because vision is the ability to see and perceive. See, even a person in a coma state, imagine there's a person in a coma state. Even in a person in a coma state can see something. But are they able to perceive what they're able to see? Not necessarily. Even a person in a coma state is effectively able to see something, but they are not necessarily able to perceive what they see. That's the difference. Okay. So they can see something, but they're not able to process or perceive what they see. So vision is basically giving machines the ability to not only see, but also perceive. Otherwise, it will be just like a camera. You just take a static image and that's it. That is see. But can machines process what they see? That's what computer vision actually is. And there are lots of incredible applications of AI in the field of computer vision. We had a masterclass, few weeks back where we talked beautifully about computer vision and some applications. We have wonderful applications, and it started all the way back a decade back when Facebook started implementing face tagging, photo tagging. If you recall, you upload a picture on Facebook, and Facebook automatically identifies bounding boxes and put bounding boxes around your faces. How beautifully Facebook is able to identify where the faces are. Not only that, it's also able to classify and predict who the people are behind the faces. So, so when you upload a group photo involving 5 individuals, uh, Facebook will automatically put rectangular tags or bounding boxes around those 5 faces. So phase one, phase two, phase three, phase four, phase five. It will automatically put rectangular bounding boxes around those 5 faces. It will not only identify where those faces are, but it will also go back and identify what those who the people behind the faces are. So what those faces are. So this is phase one, phase two, phase three, phase four, phase five. So it will not only identify who the people are, but it will also identify like where the faces are. So these are some good applications. We also have wonderful applications of computer vision that is being used by our transport department, Indian Road Transport Organization, several states. If you see, very recently, Goa Transport RTO. I was reading a news few days back. They started using computer vision software to automatically read number plates. Now it is already there in other states. If you look at Calcutta, Delhi, it's in use in a big way. Bangalore is seen in a big way. So next time you do a road violation or you're overspeeding, the cameras will automatically detect the number plate of your vehicle and an automatic challan will be issued to you. These are some wonderful applications where AI is used in the world of computer vision as we speak today. And it's a beautiful application of what we refer to as a detection. Okay. So these are some good applications. We also have great use cases of computer vision in the field of medical radiology, X-rays. You take a picture of an X-ray of a person and you try to predict whether the person is suffering from a particular kind of cancer or a particular kind of disease or not. And I think the research in the field of AI in healthcare has exponentially increased ever since COVID started. I think 2020 onwards, we have seen a monumental increase in R&D expenditure in healthcare, especially with respect to AI systems, computer vision systems, where we are seeing more and more use cases of AI being used in the field of healthcare. So where you take an X-ray of a person, or you take a CT scan of a person, or you take an MRI of a person, and how you're able to predict accurately whether a person is suffering from a heart disease or a cancer, or typical medical diagnostics kinds of use cases we are talking about. And there are significant use cases of AI in the world of healthcare, right? So security surveillance, the same way that we are able to recognize number plates of vehicles, the same way we are also able to identify threats. We are able to see increasing uses of computer vision applications in airport security cameras, where the cameras are able to identify any kind of unclaimed baggages or any kind of threats. You're able to automatically identify that, hey, here is a threat, and you're able to alert the nearest staff and all that kind of stuff. So these are again things that are happening in a big way as we speak. And to talk about more advanced use cases, something that we use on a day-to-day basis, YouTube. We talked about this in a masterclass again a few weeks back, almost a month back. We talked about we had a masterclass, a beautiful masterclass that we did on YouTube. We actually talked about how YouTube is using computer vision, and we have a wonderful use case where YouTube actually looks at, let's say, even if it's a 2 hour long video, how is YouTube able to use computer vision to automatically process that particular video? How is YouTube able to automatically process that entire video? So how we are able to automatically process that entire video, and how we are able to extract some kind of content out of it, like who are the objects present inside it? Are there any explicit things present in the video and things like that? It's more of a classification problem where we are trying to look at an entire video sequence and we are trying to classify whether it's allowed or not allowed or something of that sort. That's one way we are able to. There are lots of amazing use cases. And if I have to just maybe for a minute, if I have to just talk about the field of computer vision, what kind of applications you have, very broadly. Won't get too much into this here, but very broadly, if I have to just talk about it a little bit more technically, what the different types of problems that you are solving in the world of computer vision. This will be a very good example of the same. All of you can look at the screen here. So pretty much all the problems in advanced computer vision can be grouped into these four buckets. So point number one is classification. Classification is basically that field of computer vision which just deals with identifying objects. So I give you a picture of something and you say, hey, this is a cat, this is a dog, this is something. So that's one way to look at what classification problems are. Something that Google Photos is actually doing. So in Google Photos, you basically search, there's a pre-trained model that Google Photos is using. So we've already trained a model to identify different types of objects. That hey, uh, objects like this are apples, objects like this are what. So Google already has a pre-trained model. And next time you take a picture, Google will try to next time you take a picture, Google will automatically identify what is the object in the picture. Is it a elephant? Is it a snow? Is it something else? It's a classification problem that Google is solving, right? And if you just take an example how beautifully the Photos application is working, I will just take an example and I will just take you through uh, just a small example I'll give you. And you can see the screen right now, what I've done. I've basically kind of gone ahead and I'm actually searching for elephants on the screen. And you can see this is an example of elephants on the screen. I'm basically searching with elephants. So I basically type elephant and I hit enter. And whatever pictures I've taken, the entire repository of pictures I've taken, wherever there are elephants will be automatically displayed here on the screen. So, so whenever I take a picture, what's happening is against each and every picture, Google is basically predicting that, hey, do I see an elephant or do I not see an elephant? And if an elephant is visible, it will show that picture. If an elephant is not visible, it will not show that picture. So this is again a classification kind of problem that we are solving in computer vision, right? Uh, and is it always correct? This is just one more aspect I wanted to talk about AI systems as we get into deeper discussions here. Machine learning and AI is not always correct. It's not always accurate. So because there are a lot of cases where you can see this is elephant, but has the model identified elephants correctly here? No, there are no elephants here in the screen. But even something as advanced as Google has got it wrong. You can very clearly see that maybe the model is not trained with enough data, or maybe there's something that is mistaking for an elephant. Maybe there is something at the back, and maybe the model thinks that this looks like an elephant. So it is mistaking this particular object to be an elephant in the screen. So that's why Google has predicted this incorrectly. Even there are no elephants in the screen here. So although there are no elephants in the screen right now, Google is somehow mistakenly identifying this to be an elephant here. So these are again good use cases where Google is basically getting things wrong. So wherever there are no elephants, Google has managed to identify elephants right now. You're able to see overall. Come all the way down. There are elephants here. There are elephants here, but there are no elephants here. There are no elephants here, and there are no elephants here. There are elephants here. So wherever the elephants present, the model has predicted elephants with 100% accuracy. Again, there are elephants here. So it's working pretty well. I wanted to give you a very good example with snow. Will it work the same way for snow? Let's look at it. Very interesting. Okay. Extremely hard to predict. You can look at problems. It's gone correct here, but it's actually made a mistake here. Look at this one. I took this picture from 30,000 feet above sea level from the air. These are actually clouds in the sky, but somehow Google thought they are snow. So it's actually solving a classification problem. It's looking at a picture and it's trying to predict what am I seeing in the picture? Is it a snow? Is it an elephant? Is it something? But it clearly got it wrong. So there are a lot of cases where AI can go wrong. Okay, so whatever models that you've built, we hear this term called models, whatever models that we have built on the historical data, so somehow that model is not correct because of limited data that I use for training. So the only way to improve this is even real time as we speak. Even now, Google is getting it wrong. So we can very clearly say that even Google's models are not 100% accurate. So there are cases where you might have a picture and you might search for something and Google just got it wrong because the attributes of clouds and the attributes of snow look very similar. You might question me that time, why is it happening? Maybe the reason is because the attributes of snow and the attributes of clouds are very similar. Both are white, both look very similar. And the pixel intensity values, the pixel distributions are also very, very similar. That's why the machine is fooled into believing that they are probably snow when there are clouds in the sky. The second type of problem is called the localization problem, something we were discussing with respect to photo tagging and bounding boxes and stuff like that, number plate recognition. So localization is basically a kind of problem where you're trying to identify where is the object and what is the object. So classification, any which ways you're doing, you're trying to identify what is the object in the picture. Additionally, you're also trying to answer the question, where is the object in the picture? You're trying to put a bounding box around the object. So two problems you're trying to solve. So first, you're trying to figure out where is the object in the picture, and two, you're trying to figure out what is the object in the picture. So we are trying to figure out where is the object in the picture, and two, we are trying to figure out what is the object in the picture. So you can see the what part is basically the cat. So cat is what we are able to see on the screen right now. Now there is something called detection. Detection is more real world because detection involves multiple objects. So localization involves a single object that we are having. Detection basically involves multiple objects. And you can see that there's a picture that where we have, let's say, two cats, one dog, one duck. And when we do object detection, we are basically able to identify multiple objects and we are trying to figure out where are the objects and what are the objects. So we have a cat, we have a dog, we have a duck. So we're identifying what the objects are and where the objects are. We're able to put bounding boxes around the objects. We have total 4 objects right now on the screen. We're able to put bounding boxes around the objects and we're also able to identify what the objects are. Okay, so that is the way or how we implement object detection. And finally, we have something called instance segmentation. And as part of instance segmentation, what we do is we once again identify where the objects are. We put exact boundaries around the object and we identify what the objects are. The two-step problem we are solving. So detection is where we identify, we put bounding rectangular bounding boxes, whereas in segmentation, we basically put exact boundaries around the object. So this is the dog, this is the cat, this is the cat, this is the duck. So we put exact boundaries around the objects in segmentation. That's the way we do it. Okay. Now you might ask me that what could be a potential use case for segmentation detection. We talked about lots of use cases. I think we looked at the number plate, security, surveillance. Segmentation, a good use case could be, let's say, uh, a self-driving cars. Because in self-driving cars, you cannot put rectangular bounding boxes because that is very less accurate. You want to be very, very accurate in terms of identifying the object in a self-driving car. Okay, so just to maybe show you a small example as to how uh, it happens with respect to a self-driving car. So self-driving car segmentation, if you basically try to see a small example of the same, how it looks like. This is how the whole picture will basically look like. If you see, this is the camera view that we will typically see with respect to a self-driving car. And if you look at it right now, you see that the exact contours of the objects are visible. So we need to have the exact boundaries of where the car is, as to where the person is, where the footpath is, where the trees are, where the sky is. So the exact contours of the object need to be basically visible. So that's the way we are looking at this in the context of a self-driving car. Okay. These are some applications I wanted to talk about with respect to something called computer vision. Now coming to the world of NLP, NLP is a branch of AI that basically enables computers to analyze, understand, and generate human language. So natural language processing, mind you, language can be in any language. It doesn't have to be English. Sometimes we have a notion that it's always in English. No, it's not. It doesn't have to be English. NLP, there are lots of applications of NLP which are there in other languages also. It doesn't always have to be English. It can be other languages as well, basically. So I repeat again, NLP is basically that field of AI that enables computers to analyze, uh, understand, process, and generate human language. Okay, so that's one way to understand what AI is. It's basically text analysis. If I give you a certain text of data, then what are the different ways we can analyze that particular text, and which involves processing the data, getting the key insights, and all of these are basically part of what we do as part of NLP. Okay. Yeah, so these are some of the key NLP techniques. I'm going to just give you a little bit of a brief idea about these things as well in a small demo. I'll be showing you some aspects, but a very, very quick theory around this will be Some of the things that we do as part of NLP are tokenization. Tokenization is basically the process where we take a sentence and we basically, uh, split that particular sentence in the form of unique words. That is what we do as part of tokenization. So we have a particular sentence, let's say, and we basically split that particular sentence into tokens, unique words. Then we have something called part of speech tagging. What is part of speech tagging is basically where we look at each and every individual word and we identify what part of speech each and every individual word corresponds to. So, what is a noun, what is a verb, what's an adjective, what's an adverb, and so on and so forth. That's one way to look at this one overall. So, that's what we do as part of speech tagging. We have something called NER, and I'm going to show you a small demo of that as well. And finally, sentiment analysis. These are some use cases that we have with respect to basic NLP. And once again, before we jump into any kind of text analytics, it is extremely important to go ahead and pre-process our text data. Okay, because oftentimes text data is dirty in nature. Text data is not in the right format, and unlike structured data, unlike tabular data, where it's a lot easier to understand, unstructured data or text data can be extremely hard to inherently work with. It can be very difficult inherently to work with the unstructured data. So, which is why it is very important that we are able to study the text data, and it is very important to understand your text data and apply the pre-processing to clean our data in the right way. So it is very important to apply proper data cleaning techniques, proper text cleaning techniques, and clean and pre-process our data in a certain way. So that is also very important. What needs to be done. Okay. Rupesh, I'll come back to some of those questions. I think we can just, as we discussed, we're going to be talking about a bit of technical stuff from here. I'm going to take up your questions a little while later. So I think we can go back and come back to some of the career questions, maybe another half an hour, 45 minutes from now. Okay. All right. Now, coming to some of the basic applications of some of the basic applications of NLP in the field of some of the basic applications in the field of NLP, and I'll talk about each of these specific parts in the session also. And these are some very basic examples that we have with respect to with respect to with respect to language data. There's some good examples also that we see with respect to language data. So one example will be in the field of, let's say, emails. So can somebody tell me what is an application of NLP in the field of email? Somebody, what could be a good application with respect to emails? Anybody? Anybody wants to come in? You can actually let us know on chat. And please use the section everyone. So if you're posting on Zoom chat, just say to everyone. So that way, even all participants will be able to see your answers. Just type everyone. Okay, spam filter is a very common use case, correct? Very good. Emails, a very good use case is spam filters, correct? So the application of NLP here is more like how email applications like Gmail, Outlook, and all these applications are able to look at the message in your email. They're able to analyze the text or the specific keywords in your email, and they're able to understand, they're able to process your email. They're able to automatically classify whether that particular email is a spam or a spam. Something that also happens in the context of Truecaller. If I have to just extend the conversation back to Truecaller, Truecaller also does something very similar. All the messaging applications in Android, they also do something very similar. So emails also do something that, yes, very good application will be, what else? What else? Autocorrect, absolutely. Autocorrect will be a slightly more advanced feature where if you make a mistake in a certain text or a certain word, autocorrect feature is also enabled. Absolutely right. Yes. Right. Schedule mail report. Okay. Okay. So another good example will be anybody else? Anybody else wants to go on this autocorrect? This one. What else? What else do we see in Gmail? What other interesting features do we see in Gmail with respect to NLP, or something that you see as an interesting feature? What other features do we see in emails? Anybody else? So go back to your Gmail account. What other interesting AI related features have you seen where NLP techniques are actually used? Okay, category shopping, excellent, excellent. Auto categorization, yes. Language translation, also very general use case, correct, very good. Yes, excellent. Think of a Gmail G calendar. In fact, Outlook has this wonderful feature. In fact, Outlook has this wonderful feature where if you get an email from a particular person, let's say I email you and say that, hey, let's catch up on Monday 4 p.m. Okay, so I send you an email saying let's catch up on Monday 4 p.m. for a short meeting. Okay, so it's a small email that I send you. Let's catch up on Monday 4 p.m. for a short meeting. So what will happen is Outlook will automatically give me a meeting invite suggestion. So Outlook will automatically give me a meeting invite suggestion. Okay, so I repeat again, Outlook will automatically give me a meeting invite suggestion where they will tell me that, okay, this is what it is all about. So Outlook will automatically give me a suggestion for a meeting invite based on this one. Exactly. Calendar automation, correct. Exactly. Topic categorization, very good use case that was basically mentioned by um, twice Swaroop mentioned categorization, very good. So basically, Gmail will look at your the keywords in your particular message of the email, and it will try to categorize the email into different buckets. It's a classification problem. We are looking at the mail, and we're trying to say, is it a social, is it a promotion, is it important, is it focused? Microsoft Outlook has a focused inbox and has others. How is it able to figure out what is focused and what is other? There's a lot of machine learning happening there. Okay. And something that happens in Truecaller also. If you open up Truecaller, if people use Truecaller, you will know Truecaller also does something very similar. Truecaller also has a feature where if you go to the messages section, Truecaller groups your messages under inbox, then they have highlights, then they have promotions, and then they have spam. So how is Truecaller able to identify what is the promotion and what is the highlights and what is the inbox? So Truecaller also does a lot of categorization that way. Even OTP. Talking about Truecaller, Truecaller has a feature to identify OTPs. Okay, they have an OTP cleaner application. So you can go to OTP cleaner and it's able to look at the message present in each and every individual message. So they're able to look at the keywords of the message and they're able to predict whether the message is an OTP or not. Okay, so they're able to look at the keywords of the message. So they're able to look at the keywords of the message and they're able to predict whether the message is an OTP or not. That's one way to look at the whole thing. Yes, yes, bringing up related profile with a sending mail, correct? Yes, yes, excellent. So there are a lot of use cases. There's just one more thing I was basically looking forward to. We talked about lots of Gmail use cases. There's something else. Can somebody mention another wonderful NLP use case with emails? Another wonderful NLP use case with respect to emails? Anybody? There's one more I was looking for. Gmail already has that. Okay, yeah, I think you already mentioned that when you correct auto response is correct. So how is able to give you automated responses? And it's not only Gmail, even WhatsApp does it. WhatsApp notifications panel, if you get a text, WhatsApp will give you kind of an automated email reply that, hey, like thank you. Typical birthday messages, like even LinkedIn does it, Facebook does it. Almost every platform already has some features built in for that, where you see a particular message and there's an auto reply that basically comes up. Yes, tagging mails as priority, that's also correct. Wonderful. Social media is another big space where I would say this thing is happening in a big way, where you look at a social media update and there's a lot of scope for NLP in the world of social media. What could be some good use cases? Let's say, uh, so some good use cases here could be sentiment analysis. Sentiment analysis is a wonderful use case in the field of social media, I would say. Okay, so once again, sentiment analysis is a wonderful use case in the world of social media, where we look at the contents of the text in the message. We look at the contents of the text in the message and we try to predict what sentiment that particular message corresponds to. Okay. So so in this case, it will be more like, let's say you tweet something, a local political leader who is campaigning, or let's say the US presidential elections are also coming, 2024 elections. And if you read from President Obama's election 2008 when he was elected for the first time, that was the time when I would say you know, social media was used in a huge way. And even, Indian Prime Minister Modi, when he fought the 2014 elections, they actually shared how they leveraged social media to a huge extent. And I think if you know that uh, uh, the BJP and NDA, they have a huge data science presence in the field of politics, right? And NLP is a huge part of what campaigning is about. So there's a that will be probably one. one part of what is done. Yes, but that's actually, jokes apart, that's actually one part of what is happening. I think how we are able to use AI to automatically filter abusive comments and how we are able to tailor responses based on that. So how you're able to automatically, let's say a big political leader tweets something, a local leader tweets something, and people will keep commenting on, and how you're able to look at that entire content. It could be any leader, irrespective of the party. Everybody is doing it now. Aam Aadmi Party also has a IT cell. Congress Party also, they have set up a IT cell where they have outsourced the work to several people. And there's a huge application of NLP and text analytics in the politics as well as we see. Because you're dealing with a tremendous amount of unstructured text data based on people's surveys, based on what people tweet, based on what people are posting. And it's a tremendous amount of data that you're actually dealing with in the world of politics that way. Okay, so sentiment analysis is a wonderful field. So a good example could be, let's say you want to talk about a particular topic. You want to talk about water. So a local leader is going to about to deliver a speech in a locality, and the leader wants to understand how people feel about water, how people um, feel about water in that locality, because water is a very sentimental issue right now. I mean, just an example. I know it might just be a little ridiculous to hear. Let's say in Pakistan, if you know Karachi, very recently I was reading a news story where their foreign minister, Pakistan's foreign minister Bilawal Bhutto, he actually claimed that he takes water from a tanker. And I know it uh, maybe it might not happen in any other country in the world, but can happen only in Pakistan, that the foreign minister is blaming his own government that he's not able to get water. So it was a big gathering basically. I think it was the Prime Minister Mr. Sharif was also there, and Mr. Bhutto is basically saying that, hey, I am from Karachi and I don't get water. So he was basically addressing his constituency. He was from Karachi, and he was basically talking about people's water issues. And he was basically saying that I'm from Karachi, but I don't get water. I get water from a tanker. So now the idea is, when you give such speeches, people will start talking. There'll be online chatter. There'll be chatter. And now how do you gauge the sentiment? So people will be very, very positive about Mr. Bhutto probably, because he's basically highlighting their sentiment. He's basically talking for his constituency. So you want to see how people are responding. So these are some excellent applications where NLP is used in the world of social media, chat interactions we talked about, and other NLP-based solutions, something more advanced, I would say, Google auto completion. You start typing something, Google will automatically complete the text. Sentiment analysis, I think it cuts across the board. We already talked about it. And mobile phone keyboard, I saw a few of you mention that pointer as well to me a while back. Uh, this is also a good use case where I would say, this is working in some way. Yes, mobile phone keyboards is where you start typing something, you start typing some text, and it's able to automatically complete what you're typing. Yeah, text recommendation inserts as well. These are some other NLP based solutions we are talking about. We have Alexa, we have Siri, the conversational AI agents. These are something more advanced, something a little bit more basic that we see mushrooming all around. Again, when we talk about Google Assistant, Alexa, Siri, uh, Samsung Bixby, Microsoft Cortana, these are some advanced NLP based AI agents that we have. If we talk about something a little bit more basic, little bit more rule based, that will be the virtual assistants that are mushrooming all around us today. And when I talk about virtual assistants, I'm basically referring to something like a typical chatbot. The term chatbot is what we hear. I'm going to give you a very small example here with respect to our private sector bank, ICICI Bank. A very simple example we're going to take up. Look at this one, all of you. Look at this, Ask iPal. So ICICI Bank has a virtual assistant called Ask iPal. If I click on this one, you get a virtual assistant. This is again a classic application of NLP, but it's a very, very naive application of an AI agent. There is nothing intelligent about it. Only thing is that a series of questions and answers have been saved. A series of questions and answers have been saved. And if you ask a particular question, a particular kind of answer will be given to you. If you ask a particular kind of question, a particular kind of answer will be given to you. And again, if you ask a particular kind of question, a particular kind of answer will be given to you. So a series of question answers have been basically saved in this particular context. If there's a particular kind of question you're asking, then the answer will be given in a particular way. So this is what we call a virtual assistant. So if this is the question, then this will be the answer. This is the virtual assistant as we basically call it. Okay. And this is a series of set question answer responses. If you click on the credit card, if you see these are a set of questions you will see. And if you click on apply for credit card, there's a pre-saved response that you will end up getting. But if you ask something different, let's say if I ask ICICI Bank, what is the best credit card? Now, ideally, this is the response I'm supposed to get, right? but it doesn't understand what I'm asking. So these are issues that you will encounter in a lot of these so-called mushrooming chatbots and virtual assistants, that it doesn't quite behave the way we want it to. What is the reason? Because it is prone to mistakes. It's a very basic agent that you're seeing. It uses some very fundamental NLP-based approaches. But if we talk about something like an assistant is a lot more complex. And we will see today, we will next part of the conversation, I will actually show you that what is the technology that is working behind the scene. This one I think you can understand. This one is only for routine FAQ. Correct. Absolutely right, sir. Routine FAQ, nothing to talk about here. Internally, it's a simple set of rule-based instructions written that if this will happen. If this will happen. Nothing intelligent about it. There's no learning happening. Unlike in an assistant where there is learning happening. That is more like the Sundar Pichai's video, if you remember. How many of you have seen that video? Sundar Pichai talking about haircut appointment. How many of you remember that video? There was a keynote address he was giving at Google, and he was talking about haircut. You guys recall that? Yeah, that's an incredible one. He was basically talking live to so the Google Assistant basically booked a haircut appointment for him. So that's an example of an advanced NLP based agent. This is something very basic, something very, very elementary, something very, very rule based. But how you're able to actually understand what the customer is asking and how you're able to translate it into a response, that's basically where real intelligence kind of comes in. And that's exactly where we use neural networks and LLMs, something that we're going to be coming into right now. Okay. Okay. Now, um, a few other applications we can talk about. Text summarization. This is also a great application with respect to NLP. So somebody can tell you, maybe one of you can tell me what could be an application here, text summarization. Where do you see what kind of a domain you see this will be useful? Maybe take up a related domain where you think this will be useful. Chat GPT, yeah, that's more of a model, more of a model. There are a lot of applications. Chat GPT can be also used for text summarization. Chat GPT is not the only thing, just that it's a buzzword, it's a bit of a hype. That's why we're talking about it. But language models have been in existence for decades. It's not the first time we are seeing this. Yeah. Okay, so coming again, what is an application of text summarization, guys, quickly? Okay. Right, exactly. I think a great application of this will be if you look at especially one thing that we are seeing happening a lot in the field is basically the terms and conditions section in legal documents. If you look at the terms and conditions section, so next time when you open up a bank account, you have a entire TNC section where you see, let's say, 10 pages of terms and conditions being listed out. So 10 pages of terms and conditions of TNC being listed out. That's one thing that we typically see. So 10 pages of TNC or terms and conditions are listed out basically. And we typically don't get time to go through all the terms and conditions, right? We only want to go through a few terms and conditions and we want to get a general understanding on the basis of that. So wouldn't it be incredible if we can use summarization techniques, which is able to summarize the whole TNC thing and summarize this in the form of a few sentences? That would be a great application We can talk about news stories. I think we'll talk about these website called InShot. InShots is able to summarize a news story in 60, 70 words, 60 words. So that's another great use case we can talk about, right? Where people don't have time to read through the whole news content. Or with book summaries. Book summaries are also a wonderful use case where I think there are some good book summary websites also that we have. You can see. I'm not saying that all of them are done by AI agents because mind you that it can be prone to mistakes or errors, but I think there are a lot of websites which are actually using text summarization techniques and they're able to generate a summary of a 300-page book in a span of 5 pages. So if you have a 300-page book, how we're able to beautifully summarize the key points and the key phrases, using just 5, 6 pages. So these are some excellent applications of text summarization. This is something really incredible. It's called image captioning. Image captioning is basically a technology where we're able to see a picture and we're able to basically generate comments out of a picture, generate a text out of a picture. So this particular application lies right at the intersection of computer vision and natural language processing. So why is computer vision involved? Because we are able to look at the picture, we're able to see what is there in the picture, we're able to process the person in the picture, and we're also able to generate some text. So it's an image to text kind of a model. So we are processing the picture, and on the basis of that, we are going ahead and we are generating some text. So there's computer vision involved, and there is also NLP involved. So this is a very very advanced use case we are able to see. Exactly, that's right, really. Yeah, can somebody tell me an application of this thing? I know this looks like a fun application, but can somebody tell me a real world application of image captioning? Anybody? Traffic rules? No. Traffic rules? How? No. Accessibility? Okay. Can you stress on that a little bit more, ma'am? Really? Can you specify that a little bit more? SEO? Okay, SEO. How is pictures involved there? No, no, not SEO. SEO is a good use case of AI generally, but not of this thing, not NLP. There's no NLP, this computer vision involved here. Visually impaired? Okay. Okay. I think really has struck on a very, very good point. Yes. Yes. I text will be said aloud. Exactly. I think you already mentioned that. Sorry, I missed that. Yes. Swarup, I think camera installed for helmet detection is a good use case of AI, but there is no NLP involved in it. There is no NLP involved in that. You've given a wonderful use case of helmet detection. In fact, PPE kit detection back in the time of COVID, there were softwares that were basically used for mask detection, kit detection. Even doctors in hospitals had to mandatorily wear masks, right? It's a general use case, but there's no NLP involved in that. Yeah, but I will definitely take the point that Rennie has mentioned. This is actually a, a wonderful use case of this in the field of. Let me just take up a use case for you. So Microsoft basically has an application called Steam AI. हिंदी में ऋषभ ओनली प्रॉब्लम इज बहुत लोग ज्वाइन कर रहे हैं तो हम हिंदी में बोलेंगे तो पीपल विल नॉट फॉलो तो क्लासेस हमारे जनरली इंग्लिश में होते हैं बट देन आई आई होप जब हम डिस्कशंस करते हैं थोड़ा Q&A करते हैं तो हम हिंदी थोड़ा यूज करते हैं बट देन जनरली कीपिंग इन माइंड दैट वी हैव पीपल ज्वाइनिंग इन फ्रॉम अक्रॉस द कंट्री हम टिपिकली इंग्लिश एज अ मीडियम यूज करते हैं क्लासेस के लिए बट हाँ डेफिनेटली जब डाउट क्लियरिंग होता है क्लासेस में तो वी कैन टॉक इन इंग्लिश बट जनरली वी yeah there's an application called Seeing AI. Yes, wonderful e-learning accessible courses, correct, that's good really. Yes, there's a particular application in Microsoft called Seeing AI, and you can see right now that there is particularly a feature called scene. There's a scene recognition feature. It's an experimental feature to describe the scene around you. Okay, so there is a particular uh, experimental feature that we have basically to analyze the scene around you. So how you're able to describe the scene around. That is what the scene recognition feature is basically all about. It's an experimental feature to describe the whole scene around you. That's what the scene recognition feature basically. So the idea is that you take a picture, you basically take a camera and you take a photo. You take the camera and you basically take a picture of the entire area in front of you, and the model will automatically generate a description of the whole picture. Okay, that's the scene recognition feature. So you take a camera and you take a picture, you take a photo, and based on that particular photo, a text is generated on the basis of that particular photo. So I repeat again, you take a camera, you take a picture, you take a photo, and based on that particular photo, based on that particular picture, a certain amount of text is generated based on that particular picture. So you're basically generating text out of a particular picture. So that's the idea how scene recognition is basically happening. Talking about Rini, the example that she mentioned, we can actually use it to assist blind people to see the world. In case some of you are wondering what could be a use case, blind people can see the world, so they are not able to see. So we can have them wear some smart goggles or some kind of a camera oriented goggles they can wear. So the camera will automatically scan the 360-degree view of the image around them. So this camera will basically scan the surroundings around them, and based on the image that they are seeing, the model will basically convert it to text. Okay, so based on the image that we are seeing, based on the 360-degree image that we are seeing, the model will automatically convert that to text. So that's basically generating a visual descript. That's basically generating a visual description of the world that we are seeing around right now. So based on the image, we're going to be creating text, and from the text we're going to be converting it to spoken words. So it's basically image to text conversion we are doing. So that's one great application of how we can use this kind of an image captioning use case. Yes. Another great example of this, a team would be in the field of, let's say, uh, caption suggestion. You can talk about, let's say, next time you upload a picture on Facebook, or you upload a reel on Instagram, or you upload a profile picture on Instagram, the models can automatically recommend captions for us. Okay, so the models can automatically go back and recommend captions on the basis of these kind of things. So that's the way the whole thing will basically work out. Okay, so I repeat again, the models that we have right now can automatically recommend captions on the basis of what we have. So that's one other way how this whole thing will basically work out. So caption suggestion will be a good use case here. You can even instantly use this application today. It's seeing AI, Microsoft. You can go to the Microsoft App Store. It's not there in the Play Store. It's there in the Apple Store. You can actually take it in the App Store and you can check. So these are some excellent applications of AI that I want to talk about. And then the usual ones are language translation and other things, email response. We talked about this. Now we're going to get a little bit more technical into the conversation. We're going to be talking a little bit as to how we work with textual data. So all this while we've been talking about NLP and things. Now we'll get a little deeper into some of the different techniques that we use with respect to building these models. So what is happening behind the scenes when we are building an image captioning model or a language translation model or a sentiment analysis model? What type of text pre-processing techniques are being used? And what is happening behind the scenes when it comes to language models? When we're talking about these large language models, what are these things? What are these things and what is happening behind the scenes? So this is something that we're going to be talking over the course of the next half an hour, a little bit more technically as to what these specific topics actually are. Right. So coming to the next phase of the conversation. Now, all of you are getting a good feel. Everybody is awake. Now we're going to be coming to the slightly technical aspect of things. Yeah. Okay. Yeah. Okay. So these are some of the general text pre-processing techniques I was basically talking about a while back. So how do we basically work with textual data? So guys, one thing to keep in mind, all of you must keep in mind is when we talk about machine learning, remember, machines can only work with numbers. That's a very important thing I want to clarify, that machines can inherently only work with numbers. So next time I give it any kind of text, if I enter any kind of textual data, we have to figure out a way to convert that particular textual data into a numeric form, because inherently machines can only work with numbers. So if I enter some unstructured text data, if I enter some kind of an unstructured text data, then we have to figure out a way to convert that unstructured text data into a numeric form. Only then we can work with. Okay, so we have to figure out a way to convert that particular unstructured text data into a numeric form. Only then we can go back and work. Because machines otherwise cannot directly work with the text. It has to be first converted to a numeric form. Only then it can work. Otherwise, it cannot directly work with the text data. So you can look at a small example right now how we do that thing. This, I think we already named this thing called tokenization a while back. So if you see the text data that we have is Hyderabad is the capital of Telangana. So the very first step that we do here is we implement something called tokenization. And using that, what we do is we basically break our text data in the form of tokens. So we do something called tokenization. And then what we do is we take those tokens and then we enter into the ML model. Do we directly do that? Do we directly do that? No. So we have to somehow figure out a way to convert that particular text into a numeric form, and then we feed it to the ML model. So this is a two-part process that we go back and do. Now the next part will be how we do this conversion. So just to clarify, first step is we take the entire unstructured text data. It can span a simple paragraph, or it can span several paragraphs. Okay, so it can either span a single paragraph, or it can span several paragraphs, where we basically take that entire text data and we break that entire text data into tokens. So Hyderabad is the capital of Telangana. So we go back and take that entire text data and we break that entire text data into what we refer to as tokens. So Hyderabad is the capital of Telangana. So that's one of the things that we go back and do right now. And then what we do is we take each and every token. We now we go back and consider each and every individual token. We consider each and every individual word, and we figure out a way to convert those words into numbers and then build the ML model. Because directly we cannot take those tokens and feed it into the ML model. So we cannot directly take those individual words and we cannot directly feed it into the ML model. So we have to somehow take those individual words. We have to convert those individual words into numbers, into a numeric form. So we have to somehow take those individual words, convert those individual words into a numeric form, and only then we can go back and build a model. So that's the way we do this whole thing. Now the question is, how do we do this conversion? How do we take a word like Hyderabad and how do we convert the word Hyderabad into numbers? How do we do that? How do we do that numeric form? Because that's an extremely important fundamental aspect behind the language models. So whatever language models that we typically come across, and we have several language models. If you look at the history of language models, we have many. These are only a few examples of these large language models that we have typically heard of. So we have the likes of OpenAI, GPT-2, GPT-3. We have something like BERT. These are all different language models that we typically have, which are used for a lot of different. They're used for language translation, question answer answering, classification, text generation. Text generation is basically the idea where we have heard of these chat GPT like use cases, like where we can basically enter in something and the machine generates text for us, or even dialogue generation, conversational bots and stuff like. These are also examples that we have actually. And if we talk about any of these use cases, if we talk about any of these computational models, the fundamental thing here is basically context. Very, very important. You can see they learn word relationships. I wanted to just highlight this part. They learn word relationships and can predict words on the basis of context. This is an extremely important thing. So, how we can take an entire sentence, how we can perform tokenization, and even before we do tokenization, we have to do text pre-processing. And text pre-processing would be, let's say, cleaning the text data. Sometimes there are special characters, there are some kind of punctuations. We have to basically clean our text data of all those things. So go and remove the special characters, go and remove the punctuations, all those kind of things you go back and do. So pre-process the whole text data. So go and pre-process the entire text data. Okay, and then what we do is we go and pre-process the entire text data, and then we go ahead and after we pre-process the whole text data, then we go ahead and um, we go ahead and we tokenize. We convert the sentence into individual words, and then we take each and every individual word and we encode those words into a sequence of numbers. Okay, so then we go back and individual words. Okay, just a second, guys. Yeah, I know. Just give me a minute. Just give me a minute, please. Yes. And yeah, just a minute, please. Okay, perfect. I hope this is fine now. Okay, so basically, I was talking about the context. So how we basically the step one is basically how we pre-process the whole text data, and step two, what we do is we tokenize, and then what we do is after we tokenize, after we are able to get the individual words, how we are able to take those individual words and convert those individual words into numbers in a way that those numbers somehow represent the context of the words. So we are somehow trying to understand the meaning of Hyderabad. We are somehow trying to understand the word of ease. We are somehow trying to understand the meaning of Telangana. So at the very core of a language model is a central idea called word to vec. So what do we call it? We basically call it something called word to vec. So it is basically called word to vec. And word to vec model is basically a kind of a language model where we are basically converting words into a sequence of numbers. So we are somehow taking each and every individual word in a sentence, and we are trying to express those individual words as a sequence of numbers. And those numbers are somehow telling us the context or the meaning of what those words are. So we are simply expressing a word as a sequence of numbers. So we are taking each and every individual word, we are expressing each and every individual word as a sequence of numbers. Okay, so we are taking each and every individual word, we are expressing each and every individual word as a sequence of numbers, and then we are simply going ahead and we are basically uh, able to use those numbers, and those numbers are somehow telling us what those words mean. Okay, so we are expressing each and every individual word as a sequence of numbers, and we are basically able to somehow understand and somehow getting the context as to what those individual words mean, numbers mean. Okay, that is somehow able to learn the context of those individual words. Okay, so that is how we basically do this thing. That is the process of behind what we refer to as a word to vec. And just to give you a little bit of a sample demonstration with respect to what we do in word to vec. And remember, even before you do any of these things, there's a tremendous amount of pre-processing that needs to be done. And just to clarify, what are some examples of pre-processing that we typically do? So there's a tremendous amount of text pre-processing, and pre-processing in this case could be removing special characters, removing punctuations, all these kinds of things we will do. Let's say if we are talking about review data, if you go to a website like Twitter, somebody in Twitter would have shared their email address, somebody in Twitter would have shared their mobile number. Okay, so people would have shared some of those things. Somebody would have shared their email address, mobile number, and some of those things they would have done. And text pre-processing is basically about removing some of those special characters, some of those punctuations and things like that. That's basically what text pre-processing is all about. After you do that, you will basically oftentimes do something called stop word removal. What is stop word removal is also a bit of a technical term that we use in NLP. Stop words are basically redundant words that add no value to the analysis. So these are typically the kinds of words that do not add any specific value to the analysis. These are high frequency words like you and the. Okay, and these words actually have no significance. Like these words are not contributing anything to the meaning of the sentence or the context of the sentence. But these words are eventually are redundant words that need to be dropped. And then we also go back and use something called lemmatization. And lemmatization is a process where we take different verb forms, like for example, like, likely, and we convert it to one single base word called lemma. So how we take different verb forms and how we're able to convert different verb forms into one single base word called lemma. So that is basically what we do as part of lemmatization. Okay, so we are taking different verb forms of this particular word and how we're able to convert the different verb forms into a single central verb form, which is basically called a lemma. And then we have other kinds of things that we do, which is basically called part of speech tagging. I was just talking a little bit about part of speech tagging, how we basically look at each and every word and how we identify what part of speech each and every word corresponds to. You can see that Hyderabad is a proper noun, Telangana is a proper noun, whereas the is a determinant. And finally, we have something called NER, or named entity recognition, where we basically again take a particular sentence. You can see this is the sentence that I'm showing on the screen. Barack Obama is the American politician, and how we are able to look at that entire sentence and how we are able to basically take each and every text and classify the text into individual categories. So Barack Obama, the phrase is basically a person. United States is a GPE. 9 to 17 is a date. First is ordinal. 44th is ordinal, and so on and so forth. So we're able to look at words or phrases of words, individual phrases, and how we're able to classify those words or phrases into individual buckets, into individual categories. So this is the word or phrase that corresponds to this. This is the word or phrase that corresponds to this, and so on and so forth. So how we're able to take each and every individual word or phrase, and how we're able to classify the individual word or phrase into something. Okay, I repeat, how we're able to take the individual word or phrase and how we're able to classify the individual word or phrase into something. So this Obama is a person, American is a this, and so on and so forth. So these are some of the general pre-processing techniques that we have. And what is the reason why the context is very important? I wanted to take a beautiful example to highlight this. Look at this particular sentence also. In fact, look at this example spanning two sentences. Look at this one. Just to help you appreciate why NLP is a very very complex domain. What is the reason why NLP is very complex? Because it's not just about the presence of the words. It's not just about counting how many times a particular word has come, which is why many of those word count based models or count vectorizer based models are pretty obsolete today, if you see. Okay, so this is something that is not at all relevant. So, for example, you had I had washed my house and I had my house washed. If you look at both these sentences, it contains exactly the same words, and the words are occurring exactly the same number of times. So if you're using simple word count based models, then it will not at all work properly here. But the moment we go back, but the moment we go back and take the sequence or the context into account, the moment we go back and take the sequence or the context into account, these words have two entirely different meanings. Okay. But the moment we take the sequence or the context into account, both these words have entirely different meanings. So that's the way we understand the idea behind what we refer to as sequence models. Okay, the sequence or the context will remain very, very different in this case. That's the way to understand what is happening behind the scenes with respect to these. I had watched my house. So that's why it is very, very important to take each and every individual word. It is extremely important to consider each and every individual word and how we are able to represent each and every individual word as a vector of numbers, word to vector. So take each and every individual word and represent each and every individual word as a vector of numbers, as a collection. Okay. So that's the whole idea behind what we are doing in word-to-vec models. And very, very important, I will not get to the technical details. We use neural network for that. And the important part here is that we are able to somehow capture the context of the word and what the word basically means. Just to help all of you with a bit of a technical demonstration of the same, we can see that one as well. We can see a small technical demonstration as to what I mean to convey. We can see a small demonstration of the same here. Okay. Okay. You can see this one. Um, we can see a small demonstration of the same here. So what we do is, let's say we have the word cat, we have the word dog, we have the word person, and we have the word plane. So word to vec is basically an idea where we are expressing every word as a vector of numbers. So this is the central idea behind what we refer to as a word to vec model, and this follows into language models also. The fundamental idea is basically this: how we are able to take each and every word in the sentence, each and every token as we call it, and how we are able to express each and every word as a set of numbers. In this case, I'll just take two numbers right now, F1 and F2. What is F1 and F2? That is something we don't know. These are what we call hidden features. These are some words. Let's say cat is, let's say, zero point 0.1, comma, zero point 0.2. Dog is, let's say, 0.11, comma, 0.22. And let's say person is 0.12, comma, 0.23. And plane is something very different. Plane is something zero point 0.7, comma, zero point 0.9. And just to help you with the visual depiction of the same, if I just on the right hand side, this is actually zero. Okay, this is actually, don't treat it as six. It's actually zero. 0, 0, 0 point. Okay, this is zero. It's on a scale of 0 to 1. If I just help you with the visual representation, this is F1 and F2. And if you take a look at this thing, this is the origin. Origin is basically O. And if you see this one, cat is the word cat is present here, the word dog is present here, and the word person is present here. So there goes cat, dog, and person, and the word plane is present here. So cat, person, dog, and plane. So and you can see the coordinate representation of these individual words, and all of a sudden we have achieved something really incredible. And how is this happening? It is basically a neural network that is doing this, which is again you can ignore the inner workings of a neural net right now. But what is basically happening as the end result here is we are taking each and every individual word and we're able to somehow express each and every individual word as a vector of numbers. And these numbers are able to somehow convey to you the context or the meaning of the words. Now, what do these numbers mean? That is something we don't know. It's a black box, the hidden feature, which is typically something that we tend to hear in AI and machine learning, right? Machine models are black boxes. This is pretty much like a black box. Now, what are these numbers mean is something we don't know explicitly, but they're able to somehow convey the meaning of the words. So when we look at the word cat, dog, and person, words like this are very similar, but somehow the word plane is very different. We are able to very beautifully do clustering and visualize clustering in the context of this data. Now we don't know what these individual numbers are, but we can still say by being able to visualize these words in the mathematical space, we're able to say that okay, the word cat is zero point 0.1 comma zero point 0.2, dog is 0.11 comma zero point 0.22, person is 0.12 comma zero point 0.23. And by being able to visualize this data in a two-dimensional mathematical space, we can say that these words are very similar because the numeric representations are very similar. Whereas plane is very different because the numeric representation is very different. So by building language models, by building word-to-vec models, we are able to understand the meaning of the words, and all of a sudden we can magically go back and solve mathematical equations with words. A very popular thing that gets talked about here is this one: king plus queen, king plus man is equal to queen plus. What is the answer, guys? I know it's very obvious. What is the answer? King plus man equal to queen plus woman? Absolutely, yeah. But then imagine a machine doing it. Now, we are human beings, we have a lot of intelligence, but imagine a machine doing it. How do you basically make machines solve mathematical equations with respect to text data? This is achievable using word to vec. So we are able to solve problems like this. We are able to successfully solve problems like this today using vectorized representation of words, because we are able to represent king in the form of numbers. We are able to represent man in the form of numbers. It's just like solving a mathematical equation, just like saying this plus this equal to this plus this. So we know king is a form of let's say two numbers, man is a vector of two numbers, queen is a vector of two numbers, and then we are saying okay, what is the nearest representation here? So we can basically solve mathematical equations. The reason being that we are able to understand the context of the words. And the same way that we understood something called word to vec, we also have something called sentence to vec, doc to vec. You might be wondering that, sir, it's okay. We talked about individual words into numbers, but hey, what about entire reviews? What about entire paragraph? What about entire articles? What about entire books? How do we go back and represent that as a sequence of numbers? We have doc to vec. Because documents or sentences or phrases are collections of words. The moment we are able to convert a word in the form of numbers, we can similarly go and convert a document into a set of numbers. So these are some great applications that we have in this particular field. And just to maybe show you a beautiful visualization before I move on to the next phase of the conversation, let me quickly go and take you back to that section. So there's a beautiful pictorial representation that I wanted to show all of you right now on the screen. This is actually a small example with respect to a word to vec model that I wanted to very quickly show you. And you can see right now what's happening behind the scenes, where we have individual words and we're able to understand individual words with respect to their their vectorized representations. You can see there are total 71,291 points we have right now. And I can just go and show you a couple of examples right now. Let's say we are showing the word piano, and we can see the word piano, and we can see something very, very interesting. Isolate all 101 points, we're able to see words with respect to piano. Look at this, very, very interesting. So these are words very similar to piano: organ, lesson, synthesizer, keyboard. Incredible, isn't it? Now, remember, we have not trained the machine using the meaning of the words. We have not even taught the machine what these words mean. But using word to vec, the machine is able to understand what are the words very similar to piano. Something very similar to this use case we talked about. This was a smaller use case I displayed to you, but this is something that is happening at a larger scale here. These are the words very similar to piano. We can also go and look at something else. We can maybe go and look up something called, let's say Saturn. Okay, Saturn is basically a planet. We can look at Saturn, and we want to see all the words that are similar to Saturn. Isolate all these points, and you can see all of these are basically words similar to Saturn. Okay, look at this. Very, very interesting. Uranus, Mercury, Apollo, Gemini, Rocket, Manned, Launch, Aquarius, Mortal, Titan. Titan is the moon of Saturn, basically. Europa. Europa is Jupiter's moon, I think. Moons, Venus, Gemini, Scrub, IRBM. Okay. These are all related to space. All of these words you can see are related to space. So somehow these, so the moment we have learned how to represent a word in the form of numbers, we have somehow understood the context of the words. We have basically understood the meaning of cat, the meaning of dog, the meaning of Saturn, and now we are able to understand similar words. This is really cool how we're able to see this in action. I'm going to quickly ping the link to all of you just in case some of you want to play with it. And this particular idea lies right at the foundation of what we are able to achieve today. I know we are having a lot of craze and buzz around chat GPT, this, that, but these fundamental ideas are right at the forefront of what we are seeing today. And the very first, the very first language model, if you see, the very first word to vec model that basically came about was Google's word to vec model. This was back in 2013. This project was created back in 2013 when Google released their own language model, the word to vec model, and this was trained on the entire Google News dataset you can see right now. This was basically trained on part of the Google News dataset, 100 billion words, and each and every individual word representations we basically learned. This was a massive model, and this happened all the way back in 2013. Then we had other developments also that happened in this particular space, but I just wanted to take you back a little bit towards the history of what these language models basically, where it actually started and where the inspiration basically started from. Okay, all right. Now, what is happening behind the scenes again? Just to summarize the conversations quickly, so it is having some kind of a text input. This is basically the big picture overview of how a language model is working. You can see a language model will typically, it will basically take something as input. It will basically take a sequence of text as input, and we can basically take an example of a language translation kind of thing in this particular example. So I will give an English set of words as input, and the language model will generate a set of Hindi words as output. And behind the scenes, what will happen is a numeric representation of the text. Okay, so this particular part is very, very important. All this while the last 15, 20 minutes, I was talking about the numeric representation. Right inside the language model, this particular thing is happening. The word to vec, the numeric representation is actually happening. The encoding of each and every individual word is happening internally. So next time you're feeding in a particular text sequence, remember, you're not exactly passing in that entire English sequence as text, but you're basically passing in an encoded version of that text converted to numbers. So just to give an idea to all of you, let's say I'm basically feeding in the word the movie was great. Okay, the movie was great. So what is happening behind the scenes is what is happening. I'm not exactly passing the movie was great as one sentence, but I'm basically converting the into two numbers, movie into two numbers, F1, F2, was into two numbers, great into two numbers, and this is the vectorized representation that I'm actually passing. We're not passing the individual words, but we are converting those words into two numbers each, and that can be changed. We can either have two numbers, three numbers. We can decide how many numbers we want to use to represent each and every individual text. So we are basically having a set of 8 numbers that we're using as input, and we are feeding this to a neural network. We're feeding this to a neural network, and that is going to give us the sentiment or the output. Like, okay, the movie was great. Sentiment is predicted to be positive. That's the way the whole thing is actually working out behind the scenes. On what basis are these words converted? Well, Well, so Drishti, it's a little technical, your question. So what is happening behind the scenes is it is basically learning the context. It is basically learning the context of what words are present around it. What words are present around it. So let's say if I say the movie was great, it is so we already have a pre-trained language model. A pre-trained language model is already present, and we already have learned some encoded version of the word the. We've already learned some encoded version of the word movie, and we've already learned some encoded version of the word great. So some pre-trained language model is already available, and we're able to learn the encoded representation of these individual words. It is working on that basis. Okay. If you're looking for a little bit more technical depth, I will honor that question also for you, man. I'll honor that question for you. So if you're looking for a little bit more technical depth as to how it's happening behind the scenes, I can just take you to one more very small deck and show you. So what we do is when we are building these word vectors, we actually define a window size, right? So this is how it happens. How does word to vec work? Let's say if I give you a particular word, the sun rises in the east. So what we do is we basically take a particular word and we identify what are the words coming around it. So if I look at the word in, if I focus on the word in, I will look at what are the words coming to the right of in and what are the words coming to the left of in. So in the east rises sun. So what are the words coming to the right of in and what are the words coming to the left of in? So we are just defining what are the words coming beside the word in. So we define a window size Drishti, and we are understanding the meaning of the word in on the basis of what words are coming around. That is how we are training the neural network. And at the end of the whole process, what happens is the final result is what I actually showed you here. We will basically have the word in, and we will somehow understand, okay, what is the numeric representation of the word. Okay, we're using two numbers to represent the meaning of the, two numbers for movie, two numbers for was, two numbers for great. So total eight numbers to represent that entire phrase. The movie was great. And we're taking a sequence of eight numbers and we're generating the sentiment output. That's the way it's actually working. Okay. All right. Wonderful. Just that in reality, the process is happening a little differently. If you look at technically, it's a little different. I'm show you that also. It's actually a recurrent neural network that we are using behind the scenes. But this is the crux of what we are doing in a language model. You give it some input, give it a sequence of words in English as input. The language model will generate a sequence of words in Hindi as output. Behind the scenes, it is taking each and every one of those words and it is encoding each and every word into a sequence of numbers. And those numbers are somehow telling you the context or the meaning of the words. Okay. All right. All right. This is the very basic history of the large language models. I think it really started exploding back in this was Stanford's NLP model. Then we had Google. I showed you the transformer based architecture started coming in 20, and then 2020 is when we had OpenAI's GPT-3. GPT-3 basically started becoming extremely popular. I think this was back at the time of COVID when we had GPT-3, and then we have also exploded from there onwards. We had Turing NLP. Microsoft released one of their own models. Google released a trillion parameter model. So, but the foundations, the basics are the same. The basics are basically taking a word, taking a phrase, taking a sentence, and how we are able to represent that sentence to sequence of numbers. Yeah. No, no, no. They are always changing, really. They're always changing. The context is very important. Yeah, yeah. Oh, cat will may not be. That's what again a central idea behind transformer-based architecture, Rennie. Very good question. If you look at the word bank, bank can mean different things in different contexts, not just the word. Because bank is a noun, bank can also be a verb. I am banking on you. It's dynamic, absolutely. Based on the sentence, based on the usage of the word, this changes. In fact, this was a very, very important thing that Google's BERT architecture did. If you look at the central word-to-vec model, word-to-vec was working the way that you mentioned. If we had the word bank, there'll be only one representation. But later on, the architectures that we had, it started to incorporate the context. It depended on how the word bank was actually used. Yeah. These are different components of a language model. I think we pretty much talked about this. Right at the core of it is word embeddings. Word embeddings is the encoding part that I talked about. So first we tokenize, we do data cleaning, text cleaning, all that we do. Then we do word embeddings. We represent each and every word into a sequence of numbers. And then we use the different models and then we go back and do encoding, decoding. So right at the core of this will be the encoder decoder architecture. So just to clarify, what is happening behind the scenes is effectively what we refer to as an encoder decoder architecture. Just to very clearly clarify what a typical encoder decoder architecture basically looks like. Maybe I'll just give you a very small example of the same. See if I can show you very quick idea of what a typical encoder decoder architecture basically looks like in the field of NLP. Okay. So this is how the encoder decoder architecture will look like. You take an input sequence of text in English, and I told you English, the sequence of text in this case will be the movie was great. You take a particular sequence of words in English. So you say the movie was great, and you feed it to the encoder. Encoder is nothing but a neural network. It's a model. It's a language model that we have here. So you pass that sequence of words to the encoder. The encoder will basically take that entire sequence of words and somehow convert it to a sequence of numbers. That is what the encoder part of the architecture will do. So you take the sequence of words in English and it will basically encode it into a numeric representation. It will encode into a numeric vectorized representation, and then it will pass that to the decoder. And what the decoder will basically do is it will simply generate the whole sequence of text in Hindi. And this effectively is what is happening behind language translation. Internally, behind the scenes, the word embeddings and all are happening. But this is the big picture idea of what's happening. This is the main block that is actually involved, encoder decoder architecture. Okay, so you take the English text or you take some text. Whatever input you have, you don't directly pass it. You basically pass it to the encoder, and the encoder simply goes and encodes that text. It converts that each and every individual word into a sequence of numbers. And then you take those sequence of numbers and you pass to the decoder, and the decoder will simply generate a sequence of words in Hindi. So you take a sequence of words in English, you generate individual numbers out of it, and then you pass it to a decoder, and the decoder will basically take those numbers and convert it to Hindi, and it will generate a sequence of numbers in Hindi. That's the way the decoder will basically work out. And this is the idea behind the what we call the encoder decoder architecture overall. So encoders and decoders. So this is the idea behind the encoder decoder or the overall. Exactly. That's how. And if you talk about any of the use cases, if you talk about the text summarization use case, the same idea. You will basically give an entire text as input. The whole text, let's say the whole book, 300 pages book, we will basically go back and give as input to the encoder. The encoder will basically create a small numeric representation of the whole text, and then it will pass it to the decoder, and the decoder will simply go ahead and generate a summarized version of the text in a different language. It will do that. Exactly. ASCII code is not involved. Not at all. Not at all. Otherwise, ASCII code was a very basic kind of encoding we were doing. Yeah. So ASCII code is not at all involved. So yeah. So that's the idea of why we are using word embeddings, really. Yes, we will not be doing ASCII coding, but we are using word embedding. So step one will be tokenization. We will use some index numbers to represent those tokens 0, 1, 2, 3, and then we will take those tokens, represent them into numbers, and then we will pass it to the encoder. Okay, yeah, that's the idea. And all applications, every application we talked about so far, auto completion, everything can be fit into this encoder decoder kind of an architecture. And there are a lot of other components involved. We have things like we basically have things like attention mechanism, transformer based architecture. A lot of other complex aspects are there, but the core of large language models will be just to summarize the idea of word embeddings. Not just look at the word counts, not just look at how many times the word is coming, because many of the traditional architectures used to focus on counts, but we are looking at word embeddings, representing each and every word as a sequence of numbers. And the second thing is basically the neural network aspect, which is again a different bit of a different thing. How we are able to, yeah. Do we always need both of them? Could you? How the GPT does it? Similar way. Yeah. GPT will also be doing the same thing exactly, Anshuman. So okay, just to clarify, GPT is only the representation we are talking about. Behind the scenes, this is the whole architecture. What is the chat GPT kind of a thing? What is a language model? A language model internally is just the uh, vectorized representation of the words or the sentences or the phrases. That's the way to look at it. Now, this is the whole architecture I'm talking about. A language model per se, if you see, is the trained representation of the whole thing. So just to summarize, what is the chat GPT or what is your OpenAI GPT-2 GPT? What are these language models? These language models are just like what I showed you in that visualization, where you take the word cat and you represent the word cat in the form of two numbers. You take the word dog and you have a numeric representation of the word dog in the form of two numbers or three numbers. That's the way we look at the whole thing. We take the individual words and how we're able to represent the individual words in the form of two numbers, three numbers, four numbers, and so on. We take each and every word and how we're able to represent each and every word in the form of two numbers, three numbers, so and so. That's the way we look at the whole. Right? I hope this is clear, Anshuman. Yeah. So now encoder decoder is coming only after that. So, so your language models are basically, yeah. So this is just the whole overall architecture with respect to the use. You cannot just use a normal language model to directly do the conversion. So yeah. All right. All right. So you can imagine, Anshuman, that this is one language model and this is the second language model. Think of it that way. I think that will help you understand. So this is one language model that is used to take the text and convert it to numbers. And imagine this is the second language model that is basically used to take that sequence of numbers and basically generate another text out. Think of it as two language models basically working in tandem. Okay, think of it that way. Okay, okay. Because a language model inherently is only an encoder. It's just an encoder where we are able to take a phrase or a word or a sentence and we're able to get an encoded representation of the same. That's the way to think of what a language model is doing. Okay, just like what a word to vec model was actually doing. Yeah. All right. Okay. Any questions? Anybody? We'll have a small quiz time. These are some general challenges and limitations with respect to AI. I think we were talking about some interesting cases a while back. Definitely, data bias and fairness is an issue. That is the reason why models are often prone to mistakes. Ethical considerations are also an important thing. I think, especially in the field of NLP, it is very important to sometimes mistakes do happen. And if I just have to take you through a small example, um, yes, yes, I think this is the interesting example. Exactly, things can go wrong. Exactly, things can absolutely go wrong. And this was a interesting, tweet that came about in. So there was a person named Roshan Agarwal who tweeted back in April 30th, 17. So he was basically tweeting about, um, you know, if you can just give it a read, and you can see this is a classic case where NLP can actually go wrong. So all these virtual assistants and chatbots that we use, so sometimes they can actually go wrong. So some of these sentiments should be taken into consideration. Okay, so these kind of things can be avoided if you're using language models. But this one was using a very basic, classic rule-based architecture. But the context of the words was somehow not being captured. But the moment we are able to build a better quality model where the context is captured and all that, then this kind of a problem will typically not exist. So that's one way to look at the whole thing. Yeah, exactly. It needs work. Correct. Yeah, correct. And if you talk about the other aspect, the other limitation that we are talking about, yes. If we talk about the other limitation, I wanted to give you one more very interesting use case, and this is unfortunate. This is actually in the world of computer vision. Just to talk a little bit about the ethical aspects and the challenges with respect to AI models. So this was actually there was a person named, you know, uh, I think Eric yeah, yeah, Jackie Alsine. Sorry, this person was Jackie Alsine, and what happened was, can anybody guess what happened here? Yeah, so this happened back in 2015, 2014. Sorry, 2014. What do you think actually happened here? So what was the problem here? I'm sure some of you have heard of this case before. Yeah, what do you see actually happened here? Okay. Human detected the gorilla, absolutely. So Jackie Alsine was a human being. He was a black person, so he took a selfie with his girlfriend, and here comes Google Lens, and Google Lens classified Jackie to be a gorilla. So that's what happened, and then obviously he went to Twitter and he posted. He was extremely unhappy. Uh, he was using some curse words. You can see that. Uh, this is actually hidden, and this become a very sensitive issue for Google. By the way, just want to again highlight um, some of the challenges that goes wrong in AI system, where it went wrong, and why the model made a mistake. And I wanted to help you appreciate that these are avenues where AI systems can go wrong. NLP, we can talk about language models, this, that, even Chat GPT, you're seeing a lot of cases where it goes wrong. Now we see very interesting, lot of amazing cases कि GPT ने homework कर दिया, ये कर दिया, वो कर दिया. आधा से ज़्यादा what we hear are use cases where people are talking about, uh, all hype, but nobody actually gets to address the issues where it's creating problems. There are a lot of cases where AI can go wrong. Now you can go to Chat GPT today and you can try out. I think OpenAI, there is a section where you can actually try out Chat GPT because there's so much of craze around Chat GPT. You can also go and try it out. But definitely, uh, there are a lot of cases where it will go wrong. It's not 100% accurate, and you can try it out. The OpenAI makes it free of cost available. There's Chat GPT open. You can actually sign up. You can log in to the account and you can try out. So, but then there are a lot of cases where it goes wrong as well. Actually, okay. Yeah, so even today, even till date, if you see, because after this blunder that happened in Google's case, even today, even till date, the gorilla keyword is not there in the repository. Okay, the gorilla keyword is okay. Just a second, guys. The gorilla keyword is basically not available in the repository. Even today, if you try to search something, uh, the gorilla keyword is absolutely not available. So you cannot go back and search anything based on the gorilla. So you will not find the gorilla keyword. If you just type gorilla in Google Photos, you can see gorilla is not available, it's not visible, no results. So Google has explicitly made it a point after 2014 to remove the gorilla keyword. And the reason being that I showed you examples of snow, examples of some examples I showed you, but the gorilla keyword explicitly is not available anymore. That's one way to look at it. Okay. Yeah. These are some challenges that we face in limitations, bias, ethical considerations, computational resources. Some of these models can take a long time to run. Interpretability, the black box aspect of AI, I was talking about it, what embeddings where we were discussing that we do not necessarily know what the numbers mean. We know the context of the word, but we don't know necessarily what it means. And the training is again very, very intensive. Yes. Okay. So time for quiz. This is basically something called Moore's law. You will again, it's a bit of a technical topic, but just keep this at the back of your mind because we're discussing NLP. So just in case you hear about something like this, that so just remember that the model size and computation is increasing exponentially. And here we've actually given you this 2021 data also. This is the one I think uh, until until 2020, we had Microsoft Turing NLG, 17 billion parameter model. Then we had GPT-3, 170 billion parameter model, is almost 10 times. And then 2021, we had Google Switch Transformers, 1.6 trillion parameter model. And then even beyond that, we have GPT, Chat GPT also coming. So yeah, so a lot of advancements have happened in this particular field. Okay. Time for a quiz, and this is again something that I wanted to run in the session. We have seen a lot of topics in the class today, a lot of interesting things we have talked about, and something that we encourage in the session is to understand the audience, to understand how far you are listening to what I was explaining, and just to make sure that everybody heard the thing and everybody. We will have a small quiz, and after that we will have a quick Q&A as well. I also request people to post your questions. I'll take up any career questions, and we will also have another very important part of the conversation where we will go back and we will have a small demonstration of the platform and a small explanation of AlmaBetter what we do. So that's the next part of what we will do right now. Just a minute while I quickly share across the questions here. Okay, I'll quickly start this for all of everybody, and all of you can just go back and quickly just head over and go to this link, please. I'll quickly ping the link on chat, and everybody can go to the link, and you can all participate in the quiz. The game pin is also displayed here. You can also please use it. I'll wait for all of you to join in. We have a lot of participants today, so looking forward to all of you to join in. It will be a short 2 minute quiz, not more than that. Yeah. Okay. Others, just we're gonna wait for maybe a minute or so. Let me allow all of you to join in. Just a minute, not more than that. Yeah. Quick, guys. Yes, yes, as a guest. As a guest. You can come as a guest, no problem. You will just participate. That's it. No need to sign in. No need to sign in. You just need to participate. Yeah. Okay, come on, guys. I think let's just. No, I'll explain. I'll explain. It will be a small quiz. It will be a small quiz. So once all of you join in, then I will go ahead and start the questions. I will ask a series of questions and initiate a series of questions, and you will go and yeah. Really, have you joined in? I don't see you. I don't see your name here. Have you joined in? Uh, what issue you're facing? I just yes, yes. You can also scan the key. Yeah. Okay, just click on this. No, what's the challenge? Just join at Kahoot.it. See, I'm going to incognito and showing you. You can just click on Kahoot.it. Game pin enter karo, bas that's it. Huh? What's there to worry? Just click on this link. Huh? Just click on this link, guys. Kahoot.it. Click on it. Huh? That's it. Straightforward. So you can just click on this link. I can just ping you Kahoot.it and just click on this one. That's it. And the game pin will be 21933330. That's it. I think they should make it easy. Huh? Click on it. All. Yeah. Let me just wait for another minute or two. Not yeah. Okay. Others are also all of you have entered? Yeah. Just another 30 seconds more. Just in case some of you are facing issue before. 30 seconds more. Okay, 10 seconds more. Okay, wonderful. I'm going to just start it now. Let me see. Everybody's in. So we're going to start the quiz. So there'll be a series of questions, and you can answer the questions based on whatever options you think are appropriate. Yeah. So the first one coming on the screen. Yeah. Okay. I think the answer to the question is pretty much inherent in the question itself. Yeah, easy one. I've already got 9 answers, 10 answers. Almost everybody has responded. I think one last answer is remaining. Okay. All right, natural language generation, almost everybody got it right. Not machine translation. Machine translation is neural machine translation. That is not the case. Because we don't generate something in machine translation. Sentiment analysis also not, because that's the positive, negative sentiment, Twitter tweets. But we were talking about generation of coherent and contextually relevant text. Sentiment analysis is more of a classification problem, where you look at a particular text and you try to classify what sentiment it is. It's going to be a natural language generation. Yes, coming to the next one. Okay, we are Anna. Who is Anna? Sorry. What's your full name? What's your full name? Okay, Anna Dorothy. Sorry. Yeah, Anna Dorothy. Yeah, I hope I'm pronouncing it right. Then we have Sairam. Then we have uh, I think somebody is using the short. RC. Is it Rini? Is that you, Rini? This one? Yeah. Okay. Wonderful. Okay. So Rini is in third. You can see the results. This is also very interesting. Something we do in our classes also. I think something that we see drives engagement a lot. So when we teach you a particular topic, we also make it a point to run Kahoot quizzes, because we see people feeling very engaged after this. Yeah. Okay. Second question. Yeah. I know this is a little tricky between two options, but try to choose a more advanced option. That's the only hint I can give you. Because language models are advanced, so look at a more advanced use case. Yeah. Okay, I think this was a little tricky. Yeah, I think this was a little between speech synthesis and sentiment analysis. Speech actually involves uh, something to do with audio data also. So little debatable. I know. I think it's between option two and option four, but definitely not option one. Option one is computer vision, and option three is also computer vision, image recognition. So definitely not one and three, but it was little between two and four. I think bit debatable. But I think sentiment analysis is the right option because that involves language models. Okay, next one. All right, wonderful. I think again it was a little tricky. I think we talked about this right at the end of the session today. Lack of language diversity. So, what are some of the challenges faced by language models? Uh, okay, so low computation power is not exactly a challenge, because I think we do have enough computation power today. That is not a problem. Uh, so limited availability of training data is not a challenge again in today's world, because we have enough data available. So data and computation is not the challenge in today's day and context. So definitely not one and two. I think again it's a little between three and four. So we can say inability to handle. So lack of language diversity is very very important, because although language models perform extremely well in the context of English, but if you look at some of the vernacular languages, Hindi and other native languages, language models actually suffer today, which is why in NLP, if you see top product companies today, they are basically hiring a lot of people across different languages. They're even having language experts who can speak other vernacular languages like Tamil, Bengali, and so on and so forth. So we are seeing a huge amount of focus in the Indian context, particularly. Yeah. I think it's a little tricky between the two options, yes. But that's okay. That's okay. It's part of what MCQs are all about. But definitely not two, one and three. I hope we sorry, definitely not one and two actually. Okay. Let's come to the next one. Yeah. Okay. There's a bit of a tricky question. I know it's a little technical. That's okay. Yeah. Okay. Pre-training. Yeah, pre-training. So tokenization is different, fine-tuning embedding is different. So I think it's again it's a little tricky. But yeah, so I know the term is a little tricky and it's a little, but it's a little debatable. I take this little ambiguous. I think we can take this one. It's a little ambiguous question. So that's okay. So pre-training is again we can debate that fine. It is pre-processing and that's okay. I think it's a little debatable. Even tokenization is a kind of a pre-processing technique. Stopword removal, lemmatization is also pre-processing. So that's okay. I think this is a bit of an ambiguous question. Uh, let's come to the next one, the last one. Let's quickly wrap it up. Yeah. Future direction is something we're just testing you on what you think can happen. Again, something that is not necessarily talked about today, but I just wanted to understand how you feel about where we are going with LLM. All right, wonderful. So again, it was a bit of a tricky question, but I see some of you have still managed to do it right. Wonderful and good to see everybody's participation in the quiz. This is something that we tend to do to drive engagement, and I think we have Yaha who is the winner, followed by Reni and followed by Aziz. So wonderful! A big clap for all of you. Great job. And I think the quiz was just a way to engage you guys a little. But I hope all of you got a good learning out of the class, and everybody felt engaged, and all of you got a very good idea, most importantly, with respect to what is natural language processing, what is NLP, what is word embeddings, and what the whole philosophy of language models actually are, where they start from, what is embedding, what's an encoder decoder architecture. So we talked about quite a few technical topics also towards the end. All right. So from here onwards, the conversation moves a little towards AlmaBetter, and we're going to be getting a little deeper into our offerings and what we do and how we do things differently. And something that even I feel very passionate about because even I'm a teacher with AlmaBetter, I take classes here, and we have a very different kind of a curriculum. We have a very different approach that we actually follow, especially with respect to the bootcamp driven program that we do, the job guarantees that we provide. And we will definitely from here onwards having the team, we have Karan and the team who will be picking up from here onwards and helping all of you understand a little bit more with respect to the offerings that AlmaBetter actually has. Yeah. So once again, thank you for joining in the session today, guys. It was amazing having all of you. And do sit back and focus on the remaining part where we're going to be talking more about our offerings. Yeah, yeah. Okay. Thank,
Thank you, Sayan. That was a very
thank you, Bandhan. Yes,
informative session for sure. And I think during this entire session, learners have a lot of queries regarding how they can get into this particular field of data. So I will be just going through that particular part as well, and we'll also be taking a lot of queries of all the learners regarding uh, the Alma Better part. So you can just stop sharing that screen, Sayan. I will be the one
yes,
who
yes.
will be
Sure,
taking it
sure.
forward.
Absolutely, absolutely.
Yeah.
Sure, yes.
Okay. All right. So first important thing that one needs to understand is that it's not only about learning particular topics and getting into that particular domain. It's also about learning that topic in a very right way, right? So Alma Better is kind of a platform where we not only ensure that you're learning a particular topic, but you're doing it in a certain way that whenever you're getting a particular opportunity, you don't lose out on it, right? And that can be done best when you have good mentors around you, when you have good teachers around you, and when you have a good peer network around you, because I believe peer network is something that helps you not only grow yourself as a thinker but also as a learner. You meet with a lot of different kind of minds, and you learn a lot of things from them as well, right? So what we do is that instead of just focusing on you learning on one particular topic or something like that, we ensure that you guys are studying in groups, so that if you are good at one thing, you can share it with someone else, and if you want to learn something, you can take it from there as well. That is how a peer learning model works. So somehow we all give and take in that particular way. That is why we ensure that we are studying in groups with the students who are enrolled with us. Second thing, obviously, whenever you're doing a project, you need people who have different kind of solutions for the very same question, for the very same problem. That is why we strongly focus on working in teams when we are catering certain projects. Right here at AlmaBetter, we always believe that you should be working on real-time projects. So whatever theoretical understanding you have built up post your classes could be transformed into practicality as well. Once you have done all these stuffs, the learning part, the project part, uh, the tests and the other assignment all apart, we ensure that you're getting ready for this job, which is pretty much, it's like an industry driven program, when you can say that we offer here at AlmaBetter, right? Because you can learn a lot of things from various resources that are available on internet. But again, it needs to be relevant to what industry is asking. In this session only, while Sayan was telling a lot about different topics, he was also relating them to the real world, because that is what industry demands. And that is what we do here. We first of all ensure you're learning things, you're practicing things, you're working in teams, and you're getting ready for the jobs. Now, the next question arrives is that why AlmaBetter? Why should I use this platform? And I think when I started this entire presentation, I told one line that you need to be pretty well mentored, guided, and need to learn things according to this specific industry, right? So what we do is that we ensure that you're getting an industry relevant curriculum that is covering topics from basic to advanced. A lot of learners have this query that, I don't have that IT background. Will I be able to get into this particular field? Yes, you will, and you can. If you will study hard, you will work hard, you will get into this particular domain. I saw one of the questions out there in the chat domain when a particular learner was asking about, is it possible for me to get into a data domain if I'm a fresher? Yes, why not? If you're following the basic processes, if you're working hard towards all the assignments, projects that is being given to you, if you're in discipline, obviously you will. The best part about this particular AlmaBetter program is that we don't teach you something which has become irrelevant or which is not required in the industry, because IT industry, you need to keep yourself updated every once in a while. And we ensure that you guys are doing it. You will have live classes, just like, Sayan took a session today, very engaging session. You got in touch with Sayan got in touch with all of you. And somehow, he shared his ideas with you, you shared your queries with him, and he somehow resolved them. That is why we always believe that we should have live classes. Even if you miss the live classes, you will find out the recorded ones as well. And that will obviously help you in revising that particular topic, that particular chapter. Now, once you're done with the lecture wala part, once you have understood about the theoretical part of that particular topic, it's important to practice it. And how will you do it? Just solving, coding problems, a lot of coding problems. So here at AlmaBetter, we ensure that you're getting those coding problems in terms of assignments, in terms of assessments, in terms of quizzes. And obviously, once you're done with all these theoretical understanding, we ensure you're working on projects, because working on projects will give you a clarity that whatever you are learning is being used in this real world. We have like doubt resolution sessions, and we will have one-on-one mentorship sessions as well. Right? Mentorship session, as I already told you, it is important that you should be guided with every passing step in a particular course. It's not only about doing a particular course, but it's about doing it in a very guided way. And that is what we do. If you're going through a lot of lectures, if you're solving a lot of problems, if you have a lot of quizzes that you do, if you're working on a project, definitely you will have a lot of doubts, and those doubts are being catered here at AlmaBetter. I will be showing it how it is being done, right? Now, once you're done with all these classes, the course and the training module that we have, the boot camp that we have here for 6 months, we start preparing you for the interviews. And for that, first of all, we ensure that you're getting certain mock interviews before you get into the real world and start giving interviews. And that should also be done by a dedicated career coach. So, whatever the faculty members that we have here, whether it's the mentor, the instructors, the career coaches, they all are from the very same data industry. And that states that they have a better understanding about how that particular industry is working. And they try to impart all the knowledge they have to you, also by giving certain practical examples. Today, the natural language processing topic that was being taught, by Sai. And he gave a lot of, real examples for that as well. So that you just correlate with all those examples. This is a 100% job guarantee program that we offer. So if you're following the entire process well, if you're attending your live classes, if you're revising it through recorded lectures, if you're doing your problems, your quizzes, your assignments on a daily basis, you're practicing hard, you're working on your capstone projects, you're taking the mentorship sessions in the right way, you're getting yourself grooved by taking all these mock interviews, definitely you will end up getting the job for which you're here, the data scientist or a data analyst job, all those profiles that are available in this industry. So that is the reason, you should always choose a platform who not only teaches you, but guides you in a right way with the relevant topics that are present in the industry. This is just a pathway how you will be learning things here. So what you have to do is that obviously you go to the AlmaBetter website, you sign up there, you enroll yourself by paying a registration fees on the website, right? And you start your journey. The journey I already depicted in the previous section, the learning part, the practice part, the placement part. Post that, you sign an income sharing agreement with us. It's an agreement where we promise that we will be providing you 100% guarantee job from our end, right? And if you fail to do that, we will be refunding all the, you do not need to pay any fees to us, right? And once you sign this income sharing agreement, even the fees that we have taken to you initially while you were enrolling, we just refund it back to you. You land your dream job, obviously a minimum package of 6 lakhs per annum or above that, and you start learning your journey and gets, so and once you get your job, you start paying us monthly in EMIs, right? So once you have a job in your hand, only then you have to pay us. Anything else, you don't have to pay us anything, and even the enrollment fees that you will be paying to us initially is refunded back to you. Now, when you are part of a training program, when you're part of a boot camp, there are a lot of activities that you need to do, right? So just for the technical skills, you will have live lectures as already been discussed. You will have a lot of quizzes, you will have a lot of projects, you will have a lot of assignments, you will have group discussions, you will be working on projects. In team, you will be having a healthy discussion with your peer network as well. And that is how you will understand and evolve your technical skills. You will have your mentorship sessions as well, right? Then you will have guest lectures, then you will have your community participation. I will even tell you how this community participation works here at AlmaBetter, right? And this community participation is basically for industry exposure and motivation, right? Because if you have a lot of technical skills, you also need to understand that how you can use those technical skills in this industry, right? uh, and the final is obviously, if you're trying to get yourself into the placement program that we have here, which we term as AlmaX, you have to ensure that you are doing all your competency challenges, that is your projects, your assignments, your quizzes, your tests, and obviously you are working on your capstone projects as well. So you're working on your technical skill, you're getting that industry exposure, you are building yourself for the upcoming placement opportunities that you will be getting during this entire tenure of the course that we provide here at AlmaBetter, right? Well, we have more than 500 plus companies who are hiring from us, and they can range from product-based company to a service-based company. We have a lot of startups. Most of them are Indian startups. I hope you must have heard about names like Cred, Swiggy is there. Then we have Flipkart, Uber, Citibank, Disney plus Hotstar, Amazon, Oracle, HSBC, and then these companies ranges, because data has its own domains, right? It is used in e-commerce, it is used in IT sector, it is used in banks. So, in whatever sector data is being used, the opportunity for a data scientist, a data analyst, a machine learning engineer, it arises. And we ensure that we have that many companies with us so that you get maximum opportunities. Because the more the opportunity you will get, the more the chances that you will be getting placed by the time we are ending this particular boot camp that we have here. So we have like 500 plus hiring partners, and that is why we're pretty confident that we will be giving you 100% job guarantee from our end. Now, this is something very interesting, uh, this is a salary range of all the AlmaBetter graduates who pass from our end, basically the alumni. And if you see the highest number of students, who are placed are under the category of 8 to 9 lakhs per annum. 37% of the students do graduate here. We do promise that, we will be providing you a minimum placement guarantee of 5 lakhs per annum. But again, majority of the students, they do lie in this section of 8 to 9 lakhs per annum. There's one more thing which is very important to understand, that there are still 3% of the students who end up getting more than 10 lakhs per annum as well, right? And so if you're doing your things in a proper way, if you're disciplined enough to attend all the lectures, to submit all the quizzes, to work on all the projects, even that salary range is pretty much possible. And minimum 5 to we anyhow offer. So 5 to 7, 19% of the students do get there. 29% of them are in the 7 to 8 wala domain. 8 to 9 is something that a lot of student, they work hard for, because this is the salary range where majority of our students do get placed. But again, you should focus that in between 9 to above 10%, above 10 lakhs per annum, there are like 15% of the students who are flying in the range of more than 9 lakhs per annum. So if you're a fresher, or even if you're from a very different background, and if you're switching into data domain, a salary package of more than 9 is something which, one can happily take, because it's a good amount to start off in a very new domain where you don't have a lot of relevant experience behind. So you should eye on this particular 9 to more than 9 lakhs per annum wala, category that we have here at AlmaBetter. Just a salary distribution to keep you guys excited, because at the end of the day, the reason that we learn a lot of things, the reason for which we do all these upskillment is to earn good. So if you're doing it here, you will end up earning good. And this is how the stats has been for us. That is for AlmaBetter. As Sayan said that he's also part of us, right? And other than Sayan, we have like a lot of instructors and mentors who are part of us, like Soumya, she's a software engineer in Microsoft only. Then we have Abhinav, who is in Swiggy. Then we have Shubham, who is in Dream 11. So if you see one thing, whatever instructors and mentors that we have here at AlmaBetter, they are somehow working in the very same data domain, right? So that instead of just telling you about the bookish knowledge, they will also tell you about how things are working in this industry, which will become very beneficial for you once you will start giving your interviews, and even when you will be doing your job. Because if you know about what is natural language processing, you will somehow answer it in the interview phase one. But where to use it, where to use deep learning, what are the implications of those deep learning, what are the properties of that particular topic, you need to understand it only when you will know how that is being used in real world, that is in practicality. Even when you will be doing your work post getting yourself placed from us, you need to have this clarity that if I have learned this thing, I can use it in this particular project or in this particular uh, assignment that I'm doing currently with an organization. So it's important that you should have a practical understanding about whatever things you're doing theoretically, and that is why we ensure that we have teachers from the data domain only. These are some of the success stories. You will even find it out on the website. There are multiple students who are fresher who got themselves placed from our end. There are multiple people who have an IT background who switched into data domain. There are multiple people who are from non-IT background and they switched into data domain. There are multiple people who don't have any understanding about programming languages. They got to switch into this data domain. It's all about the discipline that you maintain. It's all about the focus that you have towards towards this course. It's all about the amount of time you're giving to this particular course. It's not only about enrolling yourself into this particular course, it's also about how well you are using all the resources that are being given to you from AlmaBetter, whether it's the projects, the assignments, the mentors, the instructors, the doubt resolution sessions. You have a lot of things that you can cater while you're with us. Multiple success stories. I will recommend all of you to go through this once. You will understand one thing, that people are getting themselves placed even if they're from a different domain or even if they're freshers. Okay, so I will be just giving you a student dashboard walkthrough before we proceed ahead, and it's pretty simple, right? So how your dashboard will look like once you will enroll yourself, right? So this is how your entire dashboard will look like. Uh, so you see in your home segment, you will get to know about the upcoming live classes that will be happening here, right? You can even add it to the calendar. Then you will come across a lot of free courses that are already there on the website. Then there will be a lot of practice coding assessment, practice quiz assessments, caption. So you will get an overview of all those things that you will be learning here at AlmaBetter, right? You can get into your profile wala segment initially, right? And you can just fill all these details out here. So if you want to get yourself updated about everything that is going around here at AlmaBetter, you can even enter your WhatsApp number here, and you will keep on getting all those updates, like your upcoming classes, any master classes, any live session that is happening right now. So this is for that only. You can enter all your education details out here. That will be definitely taught to you when you will be attending your first orientation class here. If you have any work experience, you can keep it here. The reason why I'm saying all these things to you will be briefed by me in this later part of this particular session. You can add even your social accounts. If you have certain skills, you can even add it here as well. Now, let's go to the learn part. So once you will click on this continue learning all part, you will come to know about the topics that we will be covering in this entire data science for our domain. It starts with the Python language that we teach here to the students, the data structure and the algorithm part that we have here, that is the module 2. Then we have the relational database module that we have with us, where we include the SQL part. And then we move ahead with Excel, Power BI, Tableau that we have. Again, very important tools that is being used in this data domain. Then we jump into the statistics part, where we talk about a lot of mathematics and statistics. Then we talk about machine learning, in which natural language processing is part of. Then we have the supervised models. Then we have the unsupervised models. Now, these 6 modules are something which is mandatory for all the students to cover up, because you start from learning Python, you end up learning the machine learning tools. And again, most of the companies who are hiring today, they expect a particular student to have the idea about all these basic terminologies and these chapters, these particular topics, right? Once you have done all these topics, you even have this chance that you can say a liberty that you can even go through one of these specialization courses that are there in this particular system. These are specialization courses are not pretty mandatory if you want to go ahead for the placement program that we offer. But if you want to learn more about product and analytics, you can definitely do it. If you want to learn more about machine learning, again, you can do it. If you want to learn more about deep learning, you can even do it from here as well, right? So specialization just adds more knowledge to whatever you have learned initially. So that was part about the learn section that we have here. Then we go to the practice questions, where you will have a lot of questions waiting for you, starting from the coding problems to the coding assessments to the quiz assessments part that we have. You can just click on any of the questions. You will have a question here. You can solve it here. If you want hint, you can even get it here. If there is no hint available, obviously you will not get it. And you can just submit all these questions here and can get your answers from here. So, one side by side, you will be learning things, and even you will be practicing on all those topics that you have learned. Projects, we have like 31 projects that we have here at AlmaBetter, and you have to ensure that you're at least doing 5 of them, because we have like 6 modules. So there is no point doing anything less than the modules that we have here with us when we talk about the project wala part. And the best part is that all these projects are real-time projects. That means they have been once done from those respective companies. There are projects from Airbnb, there are projects from Google Play, then we have project from World Bank, Netflix, Zomato, Android. So again, when you will be working on this project is nothing but it's a problem statement which you need to solve. So while you will be working on these projects, you will also understand that the topics that you have learned so far could be utilized in to solve a problem of a particular organization, right? And this will definitely make you more industry ready as compared to any of the theoretical sections that you have done, because then you will understand how companies or the organizations are working on those particular tools to solve their very own problem, or to maybe start something new also in their organization, how they're using their data. So that is why we have like 31 projects. You can choose 5 from the projects that we have here at AlmaBetter. This is the placement cell that we talk about, that we say as Almax, that once you complete your program of 6 months that we have, right, the boot camp program, the training program that I say here, you get into this Almax career track. where we start building on your resume part, where we give you mock interviews, where you start sitting with a career coach who gives you more idea about the kind of questions that could be taught, that could be asked to you in the real time interviews. And there will be like a few more tests that you have to give, right? And this will be again a kind of a 2 month program, right? Obviously during this phase also you will be getting an opportunity to sit in a lot of interviews, but we will just start building you more towards interview as compared to any project or something like that, right? So this is a kind of a program where we again it post that first 6 month of boot camp, you will have this 2 month of Almax career track that we have, where we will build you in a way that you start getting more and more confident towards giving interviews. We will be having business communication classes. As I already told you, resume buildup will be there. There will be like a lot of mock interviews. And then, in that particular way, we will start, uh, pushing you towards getting the job for which you have enrolled with us. So this is how our classroom looks like. So we have like classes that will be this is just like a schedule that you will be getting about the upcoming live classes that you will have, right? Now these are the classes of the last 7 days that has happened, and you can even view the class recording. So if you click on this class recording, you will end up getting a recording of the classes. So even if you miss any of the live classes, even if you want to revise your live classes, you will end up, getting that option here, right? You can just view on the class recording part, and you will start getting the access of the recorded lectures that we have here. Once your class is like, this class that is mastering data wrangling will be happening in 3 days. So once that particular class starts, obviously this join class option will become activated, and you can click on this and directly get into the live classes while apart. Mentorship sessions, which is very important. So what you can do is that you can book mentorship sessions in two ways. The first one is obviously if you have any doubts regarding any of the topics that you have, like if you, let us assume that you have a problem in understanding a bit about SQL fundamentals, you can just click on that particular topic. You can add your date and time preference here, right? And you end up, booking a mentorship session for you. Mentor is someone who is again an industry professional who has this basic understanding about how this data industry works, and he is more than happy to give you his time so that you can ask multiple questions from him as well, right? You will be getting 9 mentorship sessions, in this entire module of 6 months that we have here. And most of the students, when they're doing their projects, if they're working on any of the assignments, they do take these mentorship sessions that we have, just to get more clarification about the topics that they have studied. Other than that, you can even have mentorship sessions if you want to get certain placement guidance. It's like, if a particular company is coming up, and if you have already planned to get yourself into a particular company, you can book a mentorship session there as well. That learner will that particular mentor will come up and tell you about how that what kind of questions that company can ask, and how you need to work on your projects if you want to get selected in that particular company, right? So this very same trick being done here as well. You just have to book a session. That particular learner mentor would be there for you, giving his time to you, and it will be a one-on-one session. There will be no other learner that would be there at that particular session, so you can ask a lot of questions, so it becomes more personalized when you talk about this mentorship all apart. Then you can get into the community part as well. So here in community, what happens is that you will find out all people, everyone who have passed out from AlmaBetter, the alumni, all the instructors, mentors, team from you know learning or the placement cell. You will also find out people from admission cell as well. So it's like a mini LinkedIn for of AlmaBetter, where you end up uh, getting in touch with a lot of people who have been directly or indirectly part with AlmaBetter. So that is why we have this community. Again, it helps you a lot when it comes to peer networking or peer learning that we already discussed in the first slide. This is basically a doubt resolution forum that we have here, right? It's there at the bottom of this dashboard, My Tickets. If you click on this, you will get this particular page open. And what you can do is here, you can get into this forum wala page that we have here, and you can have a lot of questions that's already being asked by a lot of learners previously. So it will act like a question bank for you. But if you want to ask a new question, you can just post a topic. What is the title of that particular topic? The uh, the chapter from which you're asking that particular topic is being asked here. You can even have your message written, maybe your question. You can attach maybe your screenshot of your problem that you're facing, and you can just save it. The learning team will get in touch with you with the solution of this particular topic. So even if you're watching a recorded video, you can just put your questions here. Maybe if you have 3, 4, 5 set of questions with you, you can just put all those questions here in this uh, forum wala cell, or you can say the question bank that we have, or the doubt resolution bot that we have here, right? So that gets solved from the learning team, and you get the live somehow answers of the questions that you have in your mind while going through all the topics that we have. Right, so that was just the go through of walkthrough of the website that we have here. You can even check your performance from here, right? So let us assume that you're doing computer programming, so you can just see your course progress, how much it is. You can even check your cohort course progress. That, okay, my cohort has already finished 12% of the courses. You can check your module progress, how many lectures you have finished. You can check your daily quiz, how many quiz that you have performed, your capstone project, your competency challenges, and you can even compare it with people who with the people who are in your cohort to the people who are looking good to get themselves into AlmaX, right? So you can just have that comparison here. So you will have a daily tracker of your performance here at AlmaBetter. So just one more thing, since you guys waited here, and it was a long session. That is one thing that was waiting for all of you is this particular coupon code. So if you visit our website, uh, if you're entering this particular coupon code, that is LLM35, which I will also be pinging in the chat column, you will get a 35% discount on the courses that we are providing here at AlmaBetter. You just need to put this particular coupon code, just apply it there, and you will get that particular off. This is especially for all those students who attended this particular masterclass. Now coming to the Q&A part. So I believe that you guys would be having a lot of questions with you. So if you have anything that you want to ask when it comes to AlmaBetter, you can ask me. So total course duration, well, 6 months of bootcamp training will be there, and 2 months we will be taking to prepare you for the placement services. So you can say that, in within 8 to 9 months, you will end up getting your job, right? So total course duration will be ranging in this period only, 8 to 9, up to 10 months. Okay, so what will be the validity of our course? So you will be getting one complete entire year to complete this particular program, right? So ideally, we want you to complete this course in 6 months so that we can work on the placement thing and you get yourself placed. But we give you 1 year of complete validity to complete this particular program. And till when I'm able to provide job interviews and how many? There is no such capping over interviews. You will keep on getting multiple interviews. That is why I said the more the opportunity that you have, the more better it will be for you to get yourself into this industry. The enrollment fees on website is 29,999. If you will just go through it, if you're using this coupon code, I'm mentioning it here in the chat column, you will get an instant 35% discount on the enrollment fees. So it will drop down to 19,499. We have, I think when you talk about the duration for working professionals, is it the everyday time that you need to invest on the courses? So we do have our live classes 4 days in a week from 8 to 10:30. So 2.5 hours you need to invest there. And other than that, if you're practicing for maybe another half an hour, that is more than enough. So, okay, so it's PM already. It's in the evening time, because as I already told you that most of our learners, they are from the mentors or the instructors, they are from the data domain only, so industry professionals. So once they get their work done, they give you these lectures. Dilip Yadav has a question that session is recorded or live. So session is live. Once that session is done, it gets there in the recorded format as well. So even if you miss out any of the sessions, you can get the recorded sessions as well. And if you want to revise that particular topic, you will have those recorded sessions with you as well. You can, Rajnikant. That completely depends upon why you are not able to complete that particular course in that particular time period. So yes, you can. You can. It is for freshers as well as for working professional, Rene. Because obviously a lot of working professionals, they come from different background and they want to get themselves transitioned into this particular uh, field of data, and data field has its own sectors. So yes, you can get yourself in any of those sectors that we have here. No, 6 full months you need to have this. This is the minimum I'm telling you, because you have to learn everything from scratch. And it takes you 6 months to actually get yourself prepared for any of the job interviews, because we don't want that you go unprepared in any of the job interviews or any of the opportunities that we will be providing you. So you will need minimum of 6 months to learn everything from scratch. Uh, Rajnikant, you just need to elaborate your question a bit more. I don't understand what this means, like the same placement guarantees. If you're asking about the placement guarantee, I already told you that we provide 100% placement guarantee. And if you're not able to give you that placement, you don't have to pay us any of the fees. You need to be a graduate, or maybe in your final year of graduation, that works out. That could also be done, Rajnikant. If you're asking in terms of the placement, yeah, you can extend that as well, depending upon the reason why you're trying to extend it. That you have to do once you get yourself placed in one of the companies, and that will be 9999. That is 9999 for the next 24 months that you need to pay to the institute once you have a job in your hand. So, a lot of questions being asked. There would be one advice, a suggestion that I would be giving. It will be monthly. It will be monthly, Rene, for the next 24 months. Once you get yourself a job, it's there on the website, right? So, all of you can just go through the website once. A lot of things are being mentioned there. I can also recommend you that you should go to the FAQ section that we have on the website page. If you feel like you have more things that you want to discuss, you can get in touch with our team as well. We will give you more brief about the courses and the placement that we provide here at AlmaBetter. Do use the coupon code. I'm just bringing it again here to get the 35% instant discount, which is there for the people who have attended this masterclass. You can get in touch with the team only, Rajnikant, and we will be giving you more brief about that, the master degree program that we have here at AlmaBetter. There is a feedback form that's being shared above as well, right? You just need to fill that form, all of you, so that if our team tries to reach out to you, or if you have any offers regarding the courses and the modules that we provide, we get in touch with you as well. Yeah, you will be getting it, training over your mail. You will be getting it. All right. I think we have discussed a lot of queries, and again, you can go to the website. You can get in touch with our team as well. Fill this feedback form. It will help us do things better in the upcoming master classes, and this segment of master classes will just keep on going ahead. So, Karan, I believe you can just take it forward from here, and thank you so much for turning up all of the learners out here. Thank you.
Yes, thanks a lot. Thanks a lot, Manjul, for taking this up and clearing all the doubts that you can find. Guys, so we'll be closing it off here. If you have any other questions, if you want to know more about, the courses and everything, you can go on the website and register there. Somebody from the team will reach out to you, and we can take it from there. Cool. Thanks a lot for attending the class, and good to have you on. Thank you.